Okay. For you guys that are here, I just got a couple of the Sharpies. Can you guys pass it around? Do me a favor, the little white card in front of you, can you guys write your name? Because I am absolutely really horrible with remembering people's names. All right. And we'll just take that little name tag, put it right back.
Oh, thank
there.
you.
Yeah,
Yeah.
don't worry.
Sorry about that.
Okay, so the little pamphlets I got for you guys, real tiny. This is kind of use it, the presentation, use it to take notes. Some of the slides are important, and the most important stuff, that's why you got extra copies here. Some of the slides I'm taking like a full page of this stuff here, putting it on the smaller thing. If you guys think, if you guys actually want this to share or to print up later in a PDF, you know, full size, in just a bit, I already have it saved as a PDF form.
Yeah,
I can share it with you guys in the email by sharing my OneDrive, because it's such a big file. As you can see, this thing alone right here is 316 slides. So as much as, that's my fingers, sorry guys. As much as I would love to have everybody have individually 316 pages,
Wow.
to see everything bigger, you see why I had to go this route. Other stuff, this one we're going to review a little later as well. This is something that sometimes has to happen with our Connex controller and even some of the Evolution equipment, like especially the Evolution Extreme, and updating the unit. This is just a little cheat sheet that's going to walk you through using a little micro SD card in the PC computer to download it and then update your controller. Technically, as if when you read this, this is a little bit older. This is right when the Evolution Extreme came out, because we had 2.0 software in all the controllers. So this kind of almost makes you sound like they're telling you to sit down on a desk and wire up a controller and do it. You can. You can actually, the thing goes in what's called demo mode. It just powers up, and you can update the controller with the micro SD card that way. So that's what that one is for. And of course, this stuff right here, service manuals on some of the bigger stuff, some of the stuff that's incredibly important. Your variable speed condensers, the newer ones, the ones that are still out there being produced, the current Evolution Extreme, the 5-stage, and even though this one shows that it's a 987 MA series, it is still will help you out in diagnosing and looking at a 987B furnace right now. Same inducer motor. The two most popular things, inducer motor and blower motor, how to diagnose those ECM controls, all that's in there. We're going to be reviewing this stuff a little bit later on. Okay, my name is Juan Mendoza. I'm with Slakey Brothers. I'm a technical product trainer, part of our tech support team. So if you guys ever call into the office, you either get myself, you get Merle, you get Michael. One of us three is usually the ones helping you guys out. Today we're going to be going over our Evolution series. There's a lot to Evolution. Just alone with even like say the service manual there, looking at our brand, the new Evolution Extreme, we could put together a full day, sometimes even 2 full days, just to really go over every little detail on the Evolution Extreme. At least a good solid 8-hour day on it, in regards to installing it, and more importantly, how to service it overall. And servicing a lot of times is what, any of these things, sometimes what will intimidate people, just because it's communicating, it's not regular 24 volt, and so on. So what we're going to be going over today, I'm going to review some apps here in a second. We're going to go over some basic wiring. I got a little thing in there you're going to like that I can send you guys separately as well. A little cheat sheet that helps you guys how to diagnose communication faults on the Evolution when you get that indoor communication fault, outdoor communication fault scenario. And we're going to go over some basic installation tips for furnaces, basic installation for the condensers, and then as well as one thing we're going to do, probably right about this point, we're going to take a small break. the Connex controller does so much that realistically, if you were breezing through that presentation, you'll see that several slides, over 100, almost 200 slides, are just on the Connex control. Some of the stuff we're going to breeze through really quick. Some of them are just, just a quick little thing to show you guys what it looks like and so on. The Connex does so much. We will spend quite a bit of time talking about the Connex itself. And then again, diagnosis basics. There's going to be a few things we'll go over. Just diagnosing, again, we can spend all day long reviewing how to diagnose a condenser, even how to diagnose a furnace and so on. If we get to the point where maybe we need some more information here, if this is where you guys are lacking, let me ask you guys this. Alan, what's one of the most important things you want to get out of today?
Oh, really? How to diagnose?
Okay.
I'm pretty rookie in here, so yeah, once I met one of those systems, when I opened condenser coil, I saw that like 5-6 control boards on it, and I was like,
Listen,
what happened? Yeah. Oh my gosh.
Oh, that's not screwed on anymore. My apologies.
Yeah, and I was like, what happened to it? Why
Yeah.
it's not working properly, and what should I diagnose to like fix it?
This thing is very intimidating, isn't it?
Right.
Okay, Nick, what's one of the things you want to get out of today?
So I'm about installation, and it's very for me how to set up it and how to find the issues after installation process. For
Okay.
example, if I turn on the system and I have and my condenser won't turn on, what should I do?
Okay.
Should I do this about what I'm looking for and interesting.
Okay. If you guys just showed up, if you guys could write your names down on the card, because obviously this is the first time I'm ever meeting you guys, and then Vlad's trying to hide his name so I don't call on him. Vlad, what about yourself?
I have no problem with diagnostic too.
Diagnose, okay. So, again, because there's so much, and I think what I'm hearing is a little trend here, a lot of diagnosing. What we probably will end up doing, and again, I want to make sure I cater things to what you guys are needing. A lot of this stuff right here, we're going to go through really quickly. We'll go through as quickly as possible. Because I want to make sure we're able to spend commissioning the Connex. It's important because that's our brain. Part of setting up and make sure your unit's working properly is going to be in that Connex, as well as helping you out to see what's going on. So it helps you have no guesswork when you look at the Connex and you know where to look at the Connex. It's going to tell you, hey, my problem is this. My pressure switch isn't closing. My high pressure switch isn't closing. Or, I got a VCVH trip on some of the older units, things like that. So you can look at the boards themselves, or you go directly to the Connex, and that'll help you on this part here to know what it is. But again, these service manuals, and they're really, really tiny screens here. So when we get to that point, I'll have you guys pull those manuals, we'll open them up, we'll go through them, and you'll see the things that really, really intimidate people the most are going to be in there step by step, especially on the furnace and 987M. It gives you step by step, check for voltage here. It's not there, then it tells you what number to go to, and so on and so forth, okay? So anyways, we will then focus quite a bit on that. So we'll breeze through this basic stuff here as much as possible. But again, communication diagnostic, that's going to help you with diagnostics. And again, wiring to make sure, because wiring is usually what ends up happening when you have a communication fault. That's usually they go hand in hand. Okay. Anywho, for those of you guys that sometimes have to order parts and stuff, if you haven't already downloaded it, the Slikey Customer app is a great app to have on your phone, tablet, as well as using the PC website. On the PC website, slikeycustomer.com, if you guys aren't familiar with it, if you guys have access to it, whenever you want to see what kind of trainings we have available, make sure you're going in their business training. And on the business training, if you guys didn't already know this, we have almost every Monday have classes, virtual classes online. And they're not. I tried doing Evolution. I tried doing ductless on it. I don't think I did the best on those because there was way too much information to try to do in a quick little, not even the easiest way to ask questions either. But a lot of this other stuff is really a lot of good information, such as, well, on Monday I'm doing refrigeration diagnostics. We did a little indoor air quality class. We're doing like a basic heat pump class. We're doing a basic electrical diagnosis class. So this is just, this slide is a little bit older. You see my stuff is like from May and April. So if you go on to business training, you're going to see everything we offer now. And I'll show you guys a little bit later what's coming up, because there's still room for even like the Monday's class. Those a lot of times are like the quick 30 minutes to no more than an hour class. We're giving you guys NATE credit even for those, to make sure we know who's participating. We're doing a little cheesy quiz that we email you guys out. You can just fill out on the computer, because I send it off as a Word document that you can just write in your answer, send it back. It's not like you're not going to get credit if you get some stuff wrong, but it's just a little knowledge test. But it's stuff that I started creating those little Zoom classes just to keep myself busy last year around when COVID hit, before we really got busy again, because I was like, I still want a job. And then it turned out that people just absolutely loved them because I just taught what I know. I just taught the crap that I knew for the last 17 years that made me successful, that made people, always made me the guy that people call and ask for help on stuff. All right? Anyway, moving on. Slakey text and call. This is our tech support number. Whenever you guys need any help, I'll give you guys my card here a little later, but this is the main tech support line number. You can call us or text us at this number. On this, if we don't answer, it goes to voicemail. When it goes to voicemail, it gets sent to the whole entire team.
Oh.
So if at some point, maybe for whatever reason, you got a phone call from Merle or myself or Michael, and you guys got our cell phone, that's handy dandy. But this is a more precise way, because then it helps Merle out to manage our department. So that if Michael or myself are having a hard time returning phone calls within our promised 30-minute time period, it could be good or it could be bad. The good part could be that maybe we're just expanding so much that we need to add another teammate to our team. Either way, give us a call or text us. Okay? Also, Slakey Customer is where we do your warranties. Alright, how many of you guys got this Bryant Service Tech app? If you guys don't have it, I would do it. Very, really important. Now, I know you guys are a Bryant dealer, but if you're out there doing several different brands, you know, Carrier, our sister company, exact same stuff. Carrier, if you ever run into some Carrier equipment, yes, you can go on the app and you can find some parts and stuff if you need to order it out in the field. But for whatever reason, when you're looking for literature, Bryant Service Tech app works best for Bryant equipment. Carrier Service Tech app works best for Carrier equipment. Okay?
Right.
This is one of the reasons I love this right here, interactive troubleshooting. They're still working on it. They're still trying to improve upon it. They were going to do an interactive troubleshooting for the Evolution Extreme, and I think they're still working on it. But this is the cool one right here, this 987M. Because, again, there's quite a bit of the furnace I know, but the one thing that I haven't memorized because I have easy access to a computer or to my cell phone is how to diagnose the ECM components on there. The little voltages to look for, at what point that's going to tell me I got a bad motor or I got a bad circuit board. But this right here, interactive, is for the whole entire thing. Everything you have right there in that manual that I give you guys, the 987M, is right here. It's a little more simplified. Here, you simply just answer yes or no, and they will automatically take you to the next step of what to look for. In the book, it's the exact same thing. You answer yes or no in that little pamphlet, but you have to go to whatever step it tells you to. So you might read line number 9, answer yes, okay, go to line 23. And then you go to line 23, and then you read that, and then you answer yes or no, you go from there. This does all that for you. So, but it's really, really neat, really handy to have on you at all times. Okay, so our evolution system, we're going to discuss a little more about what really is a communication, what stuff really communicates with all this, but all this is like the evolution family. And the reason the Connex is right dead center is because this can control all of it. Now, just a little thing about UV lights, humidifier, and a ventilator, okay? For instance, when you tell it that you have a UV light, it's not really controlling it on or off, it's just a little timer, okay? Humidifier pad, It's a timer that you're, when you engage it, yes, it is going to activate the timer, but it does also activate the humidifier terminal for the furnace or the geothermal or the fan coil, because those circuit boards got a humidifier terminal. And so if you have a humidifier with the Connex, you don't have to put a separate humidistat. And we'll discuss that here a little bit later, but it's just a little family of the equipment. Oh, and again, your air purifier, even though it's an Evolution, again, it's just a timer. They don't communicate, but it's just a timer. Once you activate it, it's just telling it to remind you, and it'll be per cycles or per timer that you got to clean it out. Okay, so the basic stuff, wiring. Okay, and one of the most common things that'll happen in an install is a communication fault. They're like, hey, I'm commissioning my unit, and it's not finding the outdoor unit. It's not finding the indoor unit. I got a problem. So what we're going to go over is just some stuff that's going to help you to make sure it doesn't happen. Okay. So first thing is, because of the communication line, it's a DC signal. You want to make sure you don't run any of your low voltage line parallel with high voltage. You can run it across. It could be nearby it. But if you definitely lay it across and it's all around a lot of high voltage, 115 volts or 208, 230, it will pick up interference and it will bug the living crap out of you, man. Because you're going to get that customer say, hey, man, it's doing it again. I mean, it could be a week later, a day later, an hour later, or a year later, that a constant, ever so often interference. This is one of the things you have to do, is make sure it's not around electrical. Because otherwise, again, this is the biggest problem, is callbacks and the nuisance thing, and you're like, it's working. It's working now, I don't know what to do. So you run into a situation like that, communication faults. This is where we're going to go over how to get into the Connex a little later, to look for past faults, to see why it wasn't working. Because sometimes a customer doesn't really see, hey, I got a communication fault. They just say, I was turning it up and down and nothing would happen. They just won't do anything. It's because they didn't notice that it had a fault for communication. Sometimes you got to use shielded wire, and you'll see a step in regards if you have to do shielded wire here in a second. But shielded wire, you guys know what shielded wire is?
Yep.
You do?
Yeah.
Okay. So sometimes you have to use that fancier, more expensive shielded wire if you're around an area that has a lot of electrical interference. Okay. The ground on that shield only connect onto the C of the indoor unit, so the C on the outdoor unit, if you're using it for the outdoor, don't connect it on the both points. There's no C terminal on the Connex controller anyways, so if you're using it to the Connex, you don't have to worry about that, but don't connect it to the outside, only connect it to the inside. Our wires, 4 conductors, the traditional A, B, C, D. C and D is your 24 volts, A and B is your communication line. 18 gauge is fine, 4 conductors. Man, you can go a long distance with 18 gauge, which is fine. You'll see if you got to go a little bit further, you sometimes have to put a resistor, but the odds of going over that distance, we'll see here in a second, are pretty rare. Connect it onto your Connex, make sure it's nice, clean connections. This is old school. This is from our old display that we had from a long time ago. And I brought this out because this is a big no-no that they don't want you to do if you have to splice wire together. If you're doing a change out, a lot of times it's difficult to run a new line set, or it's difficult to run a whole new low voltage line to the outdoor unit. So if it's short and you got to extend a little bit, don't use wire nuts. Use butt connectors. Hell, you solder it and then shrink wrap it, whatever you got to do. Mainly it's your A and B. The A and B here is what's the main problem. When that wire twists around, that electrical charge is going through it before it exits out and comes back to the unit to communicate back and forth. That creates, this right here, creates a nuisance sometimes. And it'll work fine. It'll work fine. You'll commission it. It'll work just fine. And all of a sudden it doesn't want to work anymore. You're like, what the world? And then you get maybe a third or fourth person out there is like, well, let me try this. And sure enough, almost always, getting rid of wire nuts and just doing little butt connectors and taping it up and insulating it well takes care of that problem. So be careful if you have to extend wire out. Again, this is old school Evolution. This is what, then they didn't have Just put it in here. They didn't have these nice little plugs. You know, the circuit boards had connectors that, to make a nice clean connection, we used to just use little connectors like that. Make it nice and easy. So here's our connector here. We gotta be careful. As you can see, color coded.
Yep.
Doesn't mean anything. Doesn't mean anything. You can use whatever color you want on any one of those spots. Our regular thermostats right now, a regular 24-volt thermostat, you can be a joker and use black for R if you want, and then use R for common or for something else. It doesn't matter. Wire is a wire. The color of the wire, all that is for our industry to make it easier. So that, any of you guys ever seen the telephone guys when they're doing their stuff? The bird's nest that those guys have? The color coordination is the same thing to help them out on where the certain color wire lands when they do their Cat 5 cables, when they're putting their new connectors after they run the wire, so they all go in the same spot. That's why everything's all color coordinated to make it easier. But be careful, because this happens to be our Evolution Extreme unit. Anybody so far see what's wrong with this unit yet? Look at the picture. What's that again? The plug? Yeah, it's upside down. They, for the life of them, could not figure out what was going on, why they couldn't get it up and running. Your outdoor units, as you'll see here in a second as well, we probably mentioned it 20 times. A, B, C, there's no D. Everything since 2013 now has its own transformer to power up the outdoor board. C is optional. You'll see here in a second. C is optional because sometimes they get this weird nuisance communication fault between indoor and outdoor. Even with the brand new wire, they just get this weird nuisance. Sharing the common from the indoor thermostat with the common of the outdoor thermostat mitigates some weird little issues. But in this case, he's right on the money. They somehow managed to get that plug in there. I don't know how, but it's upside down. So just be careful. These little plugs, I'm sure you guys have probably already seen them. Just pass it around and show everybody. They got little grooves. They only go in one way. Whoever put that one in there forced it in there, and it was just hooked up wrong. When you're hooking up the thermostat, be careful of this stuff right here. I did this on purpose in my office, but let's say you got somebody who's just having a bad day and used their teeth to get the plastic off of there. All this little chewed up wiring, a little bit, just this little bit right here could cause a little bit of loss of communication and interference. So just make sure nice, clean connections. If you see this behind the wall, you got to be careful of that as well. They pull out the wire, tape it up, because again, these two touching each other will create a communication fault, and obviously the common will affect the communication. Then the AC voltage here going to the DC circuit could actually short something out, so just be careful of that. Other little things to look out for. I came up with this because I ran into this twice out of 18 years, but they were a pain in the ass to find them. And it was actually this little thing right here. All this stuff here can create interference. This is why you got to be careful when you're installing. If you go back to a house and it's been running fine for 5, 6, 8 years, always ask, hey, what have you guys done? Alarm company, installation, whatever. Maybe they did a roof. So you want to go look and see if maybe they damaged your wire. But a popular thing, all this wireless, Wi-Fi cameras, wireless, everything that's being installed in houses nowadays. All these new building automation, home automation stuff that can be installed. A lot of that stuff can create interference. So when you go to something that's been working great for a long time, get a little history. Maybe some of their stuff is interfering with our stuff if the wiring is too close to our stuff overall. These other things right here. This one in particular, had a kid who, his bedroom wall, let's say this is his bedroom right here and that's the hallway. His bed was right here, nightstand right here, and he had one of these little things that he loved seeing his hair, get all frizzy, get all crazy. But the little nightstand was here, that thing stood up. It was a little bit of a tall one. Right on the other side of the wall, was a thermostat. So every so often, when this kid would turn it on, that thing would actually interfere through the wall, and then all of a sudden, he was just playing with it. It would just make it dumb, and it would just interfere with it, and it just didn't want to work for a while. until it's been off for a bit, and then all of a sudden that thing started working just fine. One of my installers, just after going back time and time again, he's like, "Hey Juan, you think this?" I'm like, "Let's try it," because it was like a consistent, like once a week or a couple times a week of a communication fault. All this stuff here in outlet, the electrical line. So if here's the electrical, and on the other side of the wall is the thermostat. And if that electrical runs pretty close to that thermostat, and as the vacuum is running or a blow dryer is running in the room, that's an interference, which is why we got to be careful when we run low voltage next to high voltage. We got basic stuff: A, B, C, D. C is optional. Outdoor units got for a long line set. They have on the circuit board for a long line set connection. Very rarely do you really go over 200 feet, but if you ever got one run that's over 200 feet, honestly, I've run into it so little, I don't even know what it is. But you look at the install manual for the wall controller, it tells you what extra little thing you got to do, and it's mainly just put a little resistor between the two communication lines, just to kind of help eat up some of the possible interference that it can pick up on the long run. Okay. Room sensor averaging, this one is important. You can do this for zone, you can do this for an individual thermostat, and this is where offices, for instance, okay? Let's say you got just one system overall, and you want to make sure, try to keep it as even as possible overall. So it's okay, they're saying it's a little bit too warm because of the sun over there. This area is a little bit okay, so you want to average out the temperature. You need 4 sensors to do it. So if you're going to do averaging, you have to have 4 sensors overall. So you would put 1 in here, maybe you put 2 in here and 2 in this room, or 1 in each office and then 1 out here. And what this will do is they can go back to the zone sensor or to the Connex control, and it's going to just take the numbers out of these 4, and the resistance value comes back as just 1 thermistor average, and the temperature will affect each thermistor overall. So overall, it just averages the temperature on all 4. So if you ever got to do zone average or an average, make sure you use 4. And in this scenario here, and these are any 10K ohm thermistor is how the Bryant Evolution stuff works. So if you're in a pinch and all you can do is find Honeywell for the meantime, or April Air makes those that you can put it to the wall and then put a little bit of putty over it to blend it in so you can't even see the sensor in the wall. As long as it's a 10K ohm thermistor, you can use it with the Bryant Evolution stuff, or with the Bryant thermostats, period. Your wiring for your zone board. So on your zone board, you got 2 terminals of the ABCD. In order to help when you do have a problem with a communication fault or something's not working right, if you can do it this way, this is perfect on a brand new house, and this is perfect in a brand new house because everything's all open. You can run wires very easily. But if it's a replacement of a non-evolution system that was zoned, it's kind of hard to rerun all those thermostats, especially if it's upstairs, downstairs, and so on. But what they want is reserve one of the ABCDs for the equipment. So you can see ABCD to the furnace to the outdoor unit. And then the other ABCD will go to the main Connex first. And then from there you start adding all your zones. And again, this could be as many as 8. But as you can see, if you do 8 zones, you at least have one other ABCD that you can run communication from as well. So this is how you do an additional, the additional 5, zone 5 to zone 8. Anyway, so in the perfect world, they want to go from the main Connex to a zone sensor, smart sensor, to the next smart sensor, to the next smart sensor. This is just a quick little layout of only one Connex controller, 4 zones. And in this scenario, they're actually, you see zone 1 up here on the zone board? And you still got a main Connex controller. Let's say you're at a Airbnb, or you're at a bed and breakfast, little place, a spot where it could be here. Again, back to this scenario. It's zoned in 4 zones. You can put this in a mechanical room with even the furnace, or put this like in the main office. Put sensors to just read room temperature in 4 zones, and then the Conics will control all 4 zones. You don't need a smart sensor per each zone. You just need something to write a big old Dwyer, I think, you know, a little round deal. Hell, when I first started, because I didn't buy one yet, it was like a water manometer, a water deal. When I checked gas pressure, it was my good old water column meter that I just have to fill up with water every single maintenance, every single call. But combustion analyzer, to me, it's a huge expense. Some of them can be pretty freaking expensive. This one here is pretty damn nice because it's got a printer and everything. This one is like almost $2,000. It's a tool. It's an extra tool. Bryant recommends it. I kind of even always had a hard time buying one because if you ask Bryant, if you ask Carrier, if you ask Train, if you ask York, nobody gives you the numbers of what your readings should be. They won't share that with you. It's all proprietary. It is drives me nuts. Why buy something? Well, what they say is when you buy it and your unit's working perfectly, you start checking every single install or every maintenance or whatever, and you start building your own data. You start building your own self data, and then you get to a call, you're like, man, this customer's complaining that it doesn't want to work sometimes. It turns off, it doesn't ignite all the time. But when it does ignite, you check your readings on it, and you see, wow, this and this and this is way different than the other 10 houses I've looked at. It's just something to help you gauge what might be going on and some issues. It's a cool tool. I'm torn to push it because this is something that takes time for you to use it and to accumulate your own knowledge on how to use it for other calls. This little part right here, if you don't already have this number here, save that number. You can get it from us. This is actually our part number, this WSF92-10003. It's a really inexpensive part. This is just so you don't have to go to Home Depot and find little adapters yourself. You can barely see it, but it's just this little adapter here, which is a 1/4 inch to 5/16, an Allen wrench, and then a little bit of 5/16 tubing. So you buy one, you look at it, and be like, man, I can buy it. They're like $8-10, whatever it may be to buy it. But once you know what it is, maybe you can go to Home Depot in one trip and buy a bunch of them at once, and then they cost you $2 a piece instead of $10. That'll be your call. Either way, the reason you want this to check your gas pressure is because of our gas files that we're using nowadays. These tower ports. So this is a 2-stage, and this is the modulating furnace. These tower ports are right there. Okay. Whenever you go check on it, you simply are going to take your little plastic piece here. That goes on the tower port. Then this little piece goes into the top of there, and then that little smaller section, that little 1/4 inch, that's designed for these hoses. So instead of the screw in right here, you just pop out that little screw in, and you take these little 1/4 inch hoses, and it attaches right on there, and you're good to go. Makes it a lot easier to check gas pressure with that little adapter. Just a little black and white photo of what the gas files look like, even though that's some of our equipment that I went and took pictures of. Your 2-stage is going to be pretty much easy. It's just put it in low stage, you adjust your gas pressure. It's got a, oops, went too far. You got an adjustment screw here for low, and an adjustment screw there for high. If you're converting it for whatever reason to propane, this one has 2 little springs in the kit you need to order to adjust to the propane. Your modulating gas valve, it modulates. You can see it's a whole different connection there. Internally, it's going to be communicating with the circuit board, and it's going to know how much open and how much to close. But you got to calibrate it. You got to calibrate it. You got to make sure that it's done precisely. A 987M furnace will never, ever overheat. Never. Okay? Let me tell you that if you ever get a call and they got a 987M furnace, zoned or not zoned, doesn't matter, and they say, hey, there's something wrong, my heater's working, but man, it's full blast all the time. I get this on a zone house, we get calls on a zone house, I'm like, man, so much freaking air is coming out of one zone, it's loud, it's obnoxious, it never stages down, it doesn't want to do anything. They gotta have heat. It works. Sometimes that homeowner never thinks about it, it's like, what the hell, it works, it's working, I got heat, I'm comfortable, it's loud, but it works. Reason being is, it will hit on a little bit later in the diagnosis. When this thing trips on a regular old limit switch fault, it doesn't just like reset and try again like a traditional single stage furnace would. If this thing trips and it trips too many times, it won't just shut down and lock out like a regular furnace will. It will actually ramp up and go 100% airflow and 100% gas flow. So whereas on a zone unit, what will end up happening is not only sometimes they'll get too much air in one zone, but they'll get air everywhere. It'll turn off zoning. If this furnace has been tripping on high heat because the low heat was never calibrated properly, it'll go to high heat, but because it knows it needs airflow through 100% airflow for high heat, it will turn off zoning, and zoning will, I mean, you call for one zone to have heat and the whole entire house gets heat. Okay?
Wow.
And that's just from the calibrations. That's a little trick that a lot of people don't realize on this furnace when they get that call of like, hey, my zoning isn't working, or I'm getting way too much heat and way too much airflow out of just one zone, you know, a couple times. It's because it tripped on the high heat, not the high heat, on the high limit at a low or medium rate. Okay? But again, a modulating furnace will never ever trip, will never ever overheat. A two-stage furnace, same thing. Once you set the low and high, is same thing. It will never overheat, because both of these units, the Evolution line units, they have an ECM constant airflow motor, so they will constantly get you the right airflow at all times. Okay. All right. So this here, it's in the install manual. It should be pretty. It's going to be really, really small to read here, but it's just step by step of how to adjust the gas pressure on the modulating furnace. And I'll short it for you guys because it's a lot of stuff to read here. Simply, you're going to disconnect the communication line. You're not going to use your Connex controller at this point. They're going to have you use just regular jumper wires because you're going to turn this thing into a two-stage. So first thing you're going to do is you're going to set the high gas fire rate. So you turn on the unit, you call for first stage, second stage heat with regular, jumper wires on the thermostat, and you set your 3.3, 3.4, 3.5, whatever is needed for your area. You set the high. Then you got to tell this thing that I am a two-stage thermostat controlled system, and you're going to turn on SW1 number 2, and then you got to make sure SW4 number 2 is off. When these things are done this way, that's just telling the unit that I am a two-stage thermostat. I want you to work as a two-stage heating unit. Even though it's modulating, it's going to tell I want you to work as two-stage. So now when you call for W1 only, then that's where you set your low fire rate. Okay? Your low fire rate is pretty low. So 987M. When you see this chart, let me just change subjects for just a second. Specific gravity and natural gas and average gas heat value at altitude. Everybody uses PG&E. I've contacted PG&E many times to try to get clarification on their zones so I can know these precise numbers. I couldn't get any real help. In our area, around this kind of altitude and everything, you're going to be safe if you use 0.6 and 1025 or 1050. As you can see, look at your 1025, 1050, 1025, 3.5, 1050, 3.3. So if you set the high at 3.5 and you do a temperature split and it's a little bit too big of a temperature split, you can just turn it down 3.3. All that's meaning is maybe in that area the gas has a little more BTU value to it. But look at your two-stage. Where I'm going to get to, exact same 3.5, 3.3. But what I wanted to point out is look at the low fire rate. 1.5 or 1.4. I've been used to years, it's always 1.5, I'm safe, no matter what brand I ever did. 1.5 and 3.5. But on the modulating furnace, this is where a big mistake happens, and this is why units overheat, because people just didn't know. Your minimum, when you set it up for W1, 0.55. Real important right there, when you set up the low fire rate on 987M furnace, it is 0.55 for low. And for you guys, you can see, now this is, I think this is for all of them. This isn't just like a BTU rating. This is for all the furnaces. 3.3, 3.5 for the high, but 0.55 for the low. Okay? And same thing over here on the 2-stage. Turn it on. You could try the lower rating, the 1.4, and you might be good there, or even 1.5, and you'll probably be okay there. But definitely on the 987M, follow their little procedure, and you'll get used to it. After you do it once or twice, you'll memorize it. You never have to look at the book again. But just make sure you set the low fire rate, set the high fire rate first, then the low fire rate. You'll never have that unit overheat, ever. If the filter is dirty, so plugged up that it can't get any airflow going, the unit probably won't work because it'll shut down because of excessive static. And it'll tell you that there's a problem and nothing will work. And that's how you can find out you got a plugged up filter, plugged up evap coil, or a collapsed return duct, for instance. Different stuff like that. Otherwise, you'll never ever overheat an Evolution unit as long as you're setting up the gas pressure right. Especially because they're constant airflow ECM motors. We're not going to go over the 830C because we're not in this area. But the numbers for the 880s, pretty much about the same. Here's your 0.6. You can see your 1.6, 1.4 for fire rate on the low, and still 3.3 to 3.6 on the high. So, again, if you always stick to that 3.5, 1.5 on a 2-stage, you're probably going to be okay. I've done that for 17 years, never bit me in the ass. The modulating furnace will, though, if you don't set that up. LP kits, again, don't worry about the 830s because you guys don't have to deal with it. But the LP kits are all pretty generic. You can see that your 987M kit, LP, will also work for the 986. And hell, even the 925, the 926. This is like the orifices. Mainly what's going to come in this kit, and we cover the orifices, the little low pressure cutout switch, and you'll have different little baggies for the different springs for the particular gas valve, for instance, okay? Make sure you set up your gas pressure there as well. So make sure you're setting up your low and your high fire rate even there. So when you go to LP on the 987M, we're at 2,000 feet elevation. You see at the high fire rate is still 11, no matter what you do. But your minimum, when you're setting up on an LP system, the minimum instead of the 0.55 is 2.2. Whereas, again, natural gas...
987.
987, yeah.
Wow.
Yeah. On a 2-stage, look at the difference, 5.5 and 11. So again, on natural gas and LP gas, 987M, the biggest problem is people were setting them up like a 2-stage unit. They were setting up the low fire rate at like 5.5 or 1.5, and it overheats. So, all right, furnaces, the other major thing is airflow. In the Connex controller, we're going to go over airflow, how to set it up through the Connex. But because our Evolution furnace, 987M, 986T, the 880, they all can work with a regular thermostat. So you can hook it up with the regular 2-stage air conditioner or no air conditioning at all. Because they can work with a regular thermostat, I kind of did some stuff here about setting that up, airflow there. Make sure you consult each particular unit in the dip switches. So the dip switches here, SW1 on a regular thermostat, you got to decide a couple things. Right here's the first one. Do you want to do 400 CFM per ton or 350 CFM per ton? So if you want to do 350 CFM per ton, for instance, you got to turn on number 5, and on the other ones you got to turn on number 5 as well. And then your airflow, you're going to go through your airflow chart. depending on your unit. Again, this is when you're not using the Conex. When you're using a Conex control and you're doing a full evolution install, dip switches don't matter. You can get in there and flip stuff around, it's not gonna matter. The Conex will communicate and will tell the system, I have a so many tonnage outdoor unit, I want 350 CFM per ton, this is what I want you to do. But with the non-Conex, go through the dip switches and set up your airflow.
Excuse me.
Yeah,
If I have a Conex and a high-end system furnace, if I adjusted dip switches, will my Conex override these
Yeah.
dip switches?
yeah.
Okay.
So even though you got dip switches on it all, you can flip dip switches trying to get the CFM. It's not gonna do anything.
Wow.
Yeah. So the nice thing about the Conex being a communication system overall is you're telling it what the outdoor unit's tonnage is. Because for instance, you can do a 5-ton furnace and put a 3-ton air conditioning unit on there. Once the system communicates and notices that, it's gonna know it needs to dumb itself down. And it needs to slow down. We're not gonna do 2000 CFM. We're gonna do that 1200 or 1050 if it's 350 CFM per ton. It will automatically do all that for you. If you take the Conex out of there, do the dip switches, yeah. Okay. Anybody need to use the restroom real quick before we get into the Conex?
Yeah, let's do 5 minutes.
Yeah, let's do 5 minutes. I need to get some water from my throat. But we're gonna get going on the Conex. The Conex. I'm gonna try to push this through about an hour so we can spend a good hour solid on diagnosing.
Okay.
Лучше информацию слышать. Лучше информацию Слушай,
Да.
Никита, что сказал? Можно в электронном виде, да, получить это все?
Да, он сказал, что после мастер-класса я ему дам, наверное, свою почту и выложу это в общий в меню в Slack канал. Он скинет вот эту презентацию и вот эти распечаточки, которые он
Да.
тоже
Лучше это в электронном виде, чтобы не таскать с собой.
Да, конечно.
Это же пипец. Конечно, хорошо, это бумажно, но с собой не потаскаешь.
Да. Excuse me.
Yes.
I have 2 cases which I want to ask you about.
Yeah.
I don't know maybe when it's better to ask. So the first case about communication problem, and the second one about the deep sweep airflow adjustment. 'Cause,
Okay.
I have a system with the air handler, and it adjusts itself about 2000 CFM, and it's turning off by the pressure. I mean.
Static pressure?
Yeah, static pressure.
Excessive static pressure?
Excessive static pressure.
So an air handler, that's one thing I didn't go over. An air handler, there's no dip switches. Nothing. An air handler, an Evolution air handler can only work with Evolution.
Yeah, so I have Connect.
Yeah.
We adjusted to 700 CFM, and it's so it starts with 800, maybe 850. So it's higher than the adjusted
So it's like a little 2-ton unit or something?
3-ton.
3-ton?
3-ton unit.
And you're trying to, so 3 tons going to do, it could do as little as 300 CFM per ton, 350 or 400.
I don't remember.
Okay. I mean, we're going to go over it, but when it comes,
So I don't know, maybe it's better to ask when the other guys will be here.
yeah, when it comes to, when we do airflow setup, there is a whole section in here later on for airflow setup.
Awesome.
No, yeah, like I said, the Connex, this is why I wanted to take a break for a second, because the Connex, like, we used to do a class that was 3-4 hours just on the Connex, because it could
Yeah.
do way so much. So we're gonna go over it, and again, some of the important stuff I'll definitely go over is the setup. Installing it, configuring, that's easy. The rest is the setup, how to make sure you got the right airflow for your furnace, airflow for the fan coil, any kind of set points for the condenser. This little thing right here called room sensor, make sure you have it turned off, because a lot of times it creates a problem.
Oh wow.
Yeah, it's called an occupancy sensor. This little thing right here is an occupancy sensor, and
I don't know about
they used to come, well, because it's a problem for a residential house, it's a problem.
Oh.
So if you put it in the hallway right here,
Yep.
and your living room's right here, and you're over here just hanging out watching TV, and you're not walking by it, it won't turn on. It doesn't know somebody's home.
Wow.
And so it used to be a problem. It's an option because let's say you install this in a business that has split systems already, a church or even a elderly home. Maybe you can use occupancy sensing to know that people are around. But for residential, it created a problem. They used to ship them enabled, and people were like, "Why is this freaking thing shutting off? All of a sudden my AC doesn't work. All of a sudden my heater doesn't work." It's because occupancy sensing was on.
Gotcha.
Yeah. So there's that feature on it, but we'll discuss all that overall.
Awesome.
And like I said, it's airflow though is definitely discussed. Setting up the airflow.
Okay.
But you're talking about diagnosing the communication faults.
Yeah, and this is the second case. I had a problem. So this was very, I don't know. So we installed new system. We tested it for about, I think, 4 hours, and everything works fine. But after that, our electrician come and do, I don't know. So they replace lights, replace some outlets, I don't know. And after that, customer called us 2 weeks later and said that his system won't work. So it's worked and then stop. Work again, stop. Work again, stop. I come and checking it, and it was working about 3 minutes, and after that outdoor communication fault, indoor communication fault. 3 minutes again, the same problem.
That's going to be a problem with either the controller or the wire. When you lose communication to the outdoor, that's easy. You can just look at the outdoor system overall. But when you lose communication on the indoor unit, to everything, it means that between here and all of this, it's not seeing anything. So, right before I came to work for Slakey's, one of my customers was having a weird issue with hers. Her thermostat kept going out, one of those older style, right, the white ones. She was having a problem with it, and she couldn't afford to buy a new thermostat yet. So I put a regular thermostat in there for the meantime, but before I left, we put in a new Evolution Connex controller in there for her. All of a sudden, communication fault, like immediately. The weirdest thing, it was working fine with the old controller for a long time until the controller was just dead. Now it doesn't want to work at all. The only way to fix it was to put a whole new wire. Don't know what was wrong with the wire. I pulled the wire out. The wire looked good. It was, so here's a closet right here where the air conditioning is. right here is the hallway, and right here is the unit. So the line went up, over, and down. Somewhere in that process, it was interfering. It was picking up interference. So when I ran a new wire, I just ran it in the closet, up into the ceiling, over the joists, away from all electrical, down the wall. I mean, I was lucky it was really, really short. And it worked beautifully. Then the outdoor unit was having the same issue, but the outdoor unit always had a problem because the wire was messed up from rats. We had to run a whole new wire for the outdoor unit, but as well. But yeah, when you're having a problem like that,
So in my case, exactly the same. So I tried to find what the problem is. I disconnected wire and checking it with the voltmeter, everything is good. But after that, I provide new wire, just through the roll from the furnace to the outdoor unit, everything works fine. Yeah, and now, and in this case, we replace whole wire. I don't know what's.
I don't know either.
Yeah,
Are we talking about like miscommunicating between like high and low voltage, right?
No,
Like,
it's
if you're
just-
running like one wire, two wires like together.
No, we're talking the communication line right here,
Right.
where it's using that DC signal to just tell the unit itself what it's doing. It'll pick up interference, and like my scenario, my wire looked good. Don't know why it was not handling it. I put a new wire in it and it started working. I'm like, I don't know. The reason I knew how to run a new wire is I was lucky. The whole way right here, I ran the wire, closed the door, and so I had the thermostat hanging there for like a week. It's just hanging, right? Just ugly as can be, but I had the new thermostat right there hanging. She said it worked, hey, come on, it worked fine. All right, I come over, put a new wire in, and it took care of it. It was the weirdest thing.
So my question was how can I diagnose this or maybe see it? Because we spent about maybe 4 hours trying to find what's wrong with the.
I will say that would be one, that right there, and even my customer's example that sometimes we just get to the point where we just replace the wire, try it. What's the worst that's going to happen? How long is it going to, if I'm lucky and the wire doesn't take long to replace, I should have replaced that wire right away, but I didn't want to go up in the attic. I didn't have my helper with me. I'm like, I'm not going in the attic. And I put it temporarily. So if you ever want to make sure that that's what it is, if you can put a temporary thermostat, like just take the thermostat off the wall, the controller off the wall, and hang it, something like that. And if it works great, then you know, all right, Mr. and Mrs. Customer, we got to run a whole new wire now. There's something wrong with the wire.
Yeah,
So,
gotcha.
yeah.
So, and in this case, I think this something with the interference with the high voltage wire. I'm not sure because it's every 3 minutes.
Again, the other thing could be is if the problem was to come back again, and let's say it's a new thermostat, a new board, sometimes you have to do shielded cable. Because with all the electronics nowadays, sometimes it'll interfere. So you run a shielded cable, and sometimes it corrects a problem where a new wire never took care of it. New thermostat wire didn't take care of the problem, but a shielded cable did, because it's shielding it away from all that signal.
Gotcha.
That's why it is possible that sometimes you do have to do, shielded cable. Pretty good. Oh, there's no pictures of it, but yeah, you look at the manual, it talks about that sometimes you do have to install shielded cable.
Yeah. Okay, gotcha,
Yeah.
gotcha. I also had this cable in the truck.
Yeah, but I mean, unless you're doing VRF or ductless stuff, nobody really carries shielded cable. It's too expensive to really run a thermostat for it.
Yeah, but sometimes it's necessary.
Yeah, if we're doing a brand new house and I talk to them and they're going to be doing Wi-Fi this, Wi-Fi that, home automation this, home automation that, you better believe I'm telling them we're putting in a shielded cable for instead of a thermostat wire. So, okay, you guys ready?
Donuts and coffee?
What's that?
Can I offer you some donuts?
Oh, I already got some. I already had a donut. Yeah.
I have a question.
Yeah.
I have a problem with furnace at the inducer motors running constantly.
Constantly?
Yeah.
Okay.
and I don't know why I check everything, but when just when I don't know why
Which furnace is it?
it's evolution.
See, there's quite a bit of slides about it. A lot of the stuff I'm gonna be able to just go snap, snap, snap. It's just some quick information. We're definitely gonna hit up some stuff on it for the setup. The commissioning process is simple, okay? You're gonna see that in a bit. As soon as we get going in regards to the commissioning, as long as everything's plugged in the right spot, you sit by the controller, just hitting the X or yes or whatever, and it finds everything, does everything for you. So even if you don't do the advanced setup just yet, everything works just fine. But anyhow, Conus controller, not going to bore you too much with a lot of this stuff. Am I back on the screen? So a couple different models, okay? They're pretty much just depending on what the customer will want one for the looks of their house, either white face or black face. Again, it's a really, really smart controller. It does everything for you. Self-configures, helps you to control extra stuff like, say, your humidifier. For our variable speed equipment, it helps you dehumidify a house, or for winter time, it'll help you use the humidity controls in it to control a humidifier. So you don't have to add an extra control in there. If you're running to a home that really needs extra dehumidification, you can actually do this without installing a separate dehumidifier for the house itself, especially if you have a variable speed unit, because it can use a lower speed of a compressor with lower airflow to get a really cold coil and remove moisture out of the air. Okay, so again, this is just a quick little layout. As you can see, what really does communicate with that wall controller. Wall controller is Wi-Fi, so you're gonna, with the Wi-Fi, it's gonna have the app, so you can control it with your tablet, computer, basically any kind of smart device. Your wall controller can go through a wired remote sensor, okay, or just on its own. It communicates to your air conditioning unit or heat pump outdoor unit, and it communicates to your furnace, and it communicates to your zone board. Extra features are on there, like a network interface module. This is, again, you can install if you're doing evolution, it means you at least got an evolution furnace or an evolution air handler. You can, for whatever reason, if you have a scenario where they're going to wait and use an older condenser and then install another condenser in a month or 2 months, you can work evolution control, evolution furnace, or evolution fan coil with a non-evolution heat pump or non-evolution AC unit. If it's a heat pump, it's got to be a fan coil though. If you're doing a non-communicating outdoor unit, you're trying to do dual fuel, it won't be able to do it unless it's unless the outdoor unit is also a evolution unit. Anyway, so communicating wise, you can see it doesn't communicate to the humidifier. It doesn't communicate to the ventilator. It will control it though. It can work in series with it all in different ways. I mean, this is a Bryant ventilator that's non-evolution, but you'll see in the setup here where we're going to be going through it, that you can actually, when this thing does have a separate control, or let's say you have some fancy steam humidifier, some other kind of fancy humidification system that has to have its own control, but it needs airflow. There is a special way that we tell the system to turn the fan on to allow it to vent using a ventilator or using a humidifier or so on. But again, you can see just the stuff that it does communicate with, just the main components, but it can't control a lot of other stuff. All right, you have access to HVAC partners?
I think just me.
Just you? Okay.
Yeah.
So for you, one nice thing about the Evolution system, once you set it up, and especially Wi-Fi, if they're on Wi-Fi, one nice thing about it is you're going to be able to set yourself up. When the customer's creating their account, you can tell the customer, make sure to put Fuse Heating and Air as your servicing dealer. Now, the cool part about that is a customer calls and says, hey, I got this thing doing something funny. I don't know what this reads, or what's this error code. Hey, the thing's flashed something about update, or flashed something about this error or something like that. I don't know what it is. You guys need to come out. But I don't want to pay you. Well, I mean, you could do them a solid. You could do them a favor, or if you are going to do a service call and you want to have a heads up of what's going on, through the connected portal. For you, you log into your HVAC Partners account. It's for Fuse only. So you will log on and you get to the connected portal and you will only see Fuse customers. You're going to see all of your customers, and then you're going to be able to look and log onto their controller, as long as they give you some basic access. Now, you're not going to be able to change temperatures or nothing like that. Don't freak them out. Tell them I'm not going to have access to change your temperatures, but it's a thing for me to be able to look at it and like you can say once a week or every day I log on to my computer, look at it, so you can say, hey, Mrs. Smith, is your heater working okay? She's like, you know, it's funny you say that because this morning it's cold as hell in the house. Well, you can like keep monitoring all your customers. You can log on there and it'll actually flat out tell you, you know, some alerts. You got some of your customers have alerts, so you can click on it and you can say Mrs. Smith's heater tripped out on rollout switch or whatever the problem is, and then you can already be proactive. You can use that as a tool.
Could you help me to find, because I have a recall on Monday.
It's not on here. That's the Service Tech app.
Yeah.
Later on, before I go, I'll show you on mine. It's on the HVAC Partners login.
Oh, gotcha.
Okay?
Yep. Thank
All
you.
right. Anyways, but if for like yourself, if only you have access, at least before you go out or before you guys send somebody out, you can use this as a tool with the Connex to go onto the system and see what the Evolution unit is doing. You can look at error codes. You can see what it might be reading for, you know, excessive static or, you know, limit trips, outdoor condenser faults, whatever it is. So before you go out there, you can get a heads up as to what it means. Or you can look on there and see, oh, Mrs. Smith, go to this screen, press this, press that. There you go, ma'am. It's going to update on its own now. That little reminder would never come back again. And different little stuff like that. Which, speaking of updates, this is usually how the screen will pop up. This is on the older version of the Connex controller. This is prior to this version, because nothing is like 9.0. Right now we're actually at 4.04 on the current Connex controller. But they're going to get, the customer can just see this and they can say no, never update, or especially if it's a new Evolution Extreme or because of some of the stuff going on. When they see the updates available, they're just going to select it. It's going to say update, it's available, select yes, and then it automatically does it for them. Some basic, I mean, this is the wall control. This is just basic do's and don'ts for any kind of thermostat. You know, mounting it nice and tight and flush to the wall. Just stuff that we don't need to really go through, but configuring and commissioning. If you have a zone system, if you power up everything so that you don't, so nothing gets confused later on. This is on the smart sensors. Every smart sensor won't self-configure what zone it is. It will immediately just say I'm zone 2. So one problem happened and people forget to go on there and change the smart sensor zoning. So before you plug in that Connex, make sure your smart sensors are plugged in. Make sure you have them all addressed as I'm zone 2, I'm zone 3, or whatever it may be. If it's just an upstairs, downstairs, just 2 zones, you don't have to worry about it. Plug it in, you're ready to go. But if you have more than 2 zones, more than one smart sensor, make sure you're going in there and adjusting the zone for that smart sensor. And again, we're going to be breezing through some of this stuff because it's pretty generic. It's just going to start reading this. Searching for indoor unit. It found the unit. At any point, if it doesn't find the indoor unit or it doesn't find the outdoor unit, it's going to stop. It has to find the indoor unit minimum for it to even go on to the next step. Okay? If it doesn't find the indoor unit, crap. Let me see what my problem is. And then go from there. Obviously, if we're here, it means that that indoor unit has power. But now there's something wrong with the communication signal between the Connex and the indoor unit. Now searching for outdoor unit. Okay, so again, this is a scenario if you're installing a Connex system or Evolution system with a non-Evolution outdoor unit, you're going to get this: outdoor unit not found. Please select type of what you have. You're going to tell it AC single stage, AC or heat pump 1 stage, or none. If this ever has to happen, you cannot control a 2-stage unit. If you ever have to control, and it's going to stay there permanently, if you're installing an Evolution furnace, Evolution control, with a 2-stage non-Evolution outdoor unit, you have to install what's called a network interface module. That little module just basically is going to allow the system to work as 2-stage instead of just 1 stage. Okay, simple as that. But you keep going on. If it's a heat pump, you're going to tell it whether if it's a heat pump or air conditioning unit, and if it's not an evolution, you're telling it what size it is. That's important because now it's going to know what kind of airflow to do. Because again, your Connex controller is doing your airflow adjustments for you. Once you tell it the 1.5 tons, 2 tons, or whatever ton that unit is, it will adjust airflow accordingly. Okay, if you're installing one of the variable speed units, by this point it's found that it's 186 or 284 or 189, 288. It's going to give you an option, and you want to go in there and select what evap coil you have. It's going to help out because you're going to see you can use the Connex to help you charge the unit to make sure your charge is precise. Either it'll check the charge for you, or it's going to tell you exactly how much more refrigerant to add to the system. Okay, that's only if it's a variable speed stuff. If it is an ADP coil, for whatever reason, if the ADP coil matches up to be more efficient than a Bryant coil, there's no ADP coil in there. You're going to have to just fudge it and put a fake number in there, and then just do your own math of how much approximately to add, check the charge, and go at it from there. Electric heat, if it's a heat pump. Again, we're gonna breeze through some of this stuff because it's pretty basic. Again, commissioning. Hydronic, the controller can do a hydronic system. You just need a different interface relay kit for hydronic. That's all part in the whole system if you're doing hydronic, but you're just telling them whether you do or don't have it. SAM module, which I guess are pretty hard to find. The system access module is for those people who are doing a home automation system. This allows home automation to communicate with the Connex. And again, if it does or doesn't, it'll tell you it's searching for that, and then searching for zoning. It goes on, tells you what it found. And like I said, in this scenario, you got the main user interface is always one. And smart sensor, remote sensor. For whatever reason, this application that chose to do a remote sensor and a smart sensor combined. But again, it's going to tell you what it found. You're going to tell it what kind of filter, whether a humidifier is installed or not, UV lights, and then it just tells you a little bit of equipment summary. Then it does its airflow check. Duct assessment, if it's zoned, it's going to be turning on and off all these zones. So if you do have 8 zones, for instance, it's going to take its time to do all of that. But it'll, you just hit the next button, and then once it's all done, it tells you how much each one can handle. And then you're done. At that point, it is commissioned, what they call commissioning. It's just installed. You're ready to go. You can turn the heater on, turn the cooling on. Heater should work right away. For whatever reason, on the Evolution stuff, after it commissions, sometimes 10-15 minutes later, it'll finally let the air conditioning work. It's just kind of kicking itself in the rear end and making sure everything's all set up right. So don't be surprised if you finish right here and you're like, man, it's hot as heck in this house, and you try to turn on the air conditioning. It could be 10-15 minutes later. At this point, you guys are probably calling me, and you're like, hey, hold on, oh, this thing just came on. Never mind, dude. And then hang up. Because it happens. All right, it'll happen. Anyway, standby mode. You're ready to rock and roll. But we're going to talk about advanced configuration. We're going to try to cover as quickly as possible. Yeah, we're doing all right. This is a very important screen right here. So I'm missing the first screen. So before you get to this screen right there, you see a little arrow right here. There's a preliminary menu, and then to get to this menu here, there's a little arrow down here. You press that little arrow, and then you get this screen here. This one right here is an important one. The service. We'll talk about later. Again, this is where you're going to set up the Wi-Fi connection for them. But this is an important one. Service. You're going to press it and hold it for 10 seconds. It'll turn like a little bit of a shade green. It'll be greenish color. You let go, and that takes you here. So this is the 2 pages. This is page 1, page 2, and this is page 3. And you can see to get from this page to this page is the bottom arrow. This is the second page. You go up, goes to this screen. Press down, goes to this screen. Okay? So this is where you pretty much do a lot of stuff. Like if you need to look up for software upgrades, if you need to update the software on it, or if you want to find out if there's software update available for it, you go there. Now, refrigerant charging is white right now, because in this, when they were helping us out to get us these slides, this unit was connected to a variable speed unit. Refrigerant charging is only available on the variable speed stuff. And what's really, really cool when you get to like the Evolution Extreme stuff is because it's registering pressures, temperatures, subcool, superheat, it does it all for us. Really, really nice. Real quick on the Bryant Service Tech app, the other nice thing about that Bryant Service Tech app, now you have an HVAC Partners account. When you go do an Evolution Extreme, the Bryant Service Tech app will connect to that unit very easily. You have to have a valid HVAC Partners account. If you have some lead installers that you want to give them access to, you don't have to give them your login credentials. To create the account, whoever is the moderator for your guys' main account for HVAC Partners,
Yep.
they can create little sub accounts
Oh, wow.
for your own employees.
Mm-hmm.
Okay?
Okay.
That way, you know, Alan goes up to the job site and the Evolution Extreme, I love. I can leave all my tools in the truck, walk up to it, click, wait, and then I'm already checking my subcool, my superheat, my voltage. I pretty much checked it all out. There's my maintenance. I take a screenshot, one page, screenshot, second page, then I turn it off, rinse it off, whatever, turn it back on, and my maintenance is done. Or update the software, or I can find out what's wrong with the unit if it's not working. And I can look at the error codes there. This is without even any tools in my hand. I can know if there's an error code or if there's software update or whatever might be going on. Then I can go walk back to the truck and grab my tools and do whatever I got to do. All right. Anyway, we're gonna focus on equipment on the Conex stuff. But we're gonna the first tab, equipment summary. That exact same screen you had earlier, just tells you what you have. So let's say you're on the phone and you're trying to get some help on something, and we just want to have logged in the model number, serial number of the unit. You got it right here. All your model numbers and serial numbers, your equipment, your basic equipment summary will be there, to at least for us to know what equipment you have. Installation. All right. If you install a furnace, you commission it, you're all good to go. Now you're coming back in March or April and you're installing the condenser because they weren't ready for it, whatever it may be. You have to go do a full reinstall. Because if you connect the condenser and then you go air conditioning, it's not going to let you do anything. It's not going to register an air conditioner at all. It won't let you run air conditioning. Anytime you add or subtract a piece of equipment from the unit, that's Evolution, you have to do a full reinstall. So in this scenario, you want to know airflow, you can do an airflow verification test. But in this case, if you're adding the air conditioner, or for whatever reason, you put in a newer style Evolution furnace, maybe the wrong one was installed, whatever was happening, you just do a full reinstall and it does the whole commissioning process all over again. Okay? Setup is the important one. This is where we're going to be going through a lot of stuff for setting it up, because it can control a lot of stuff. Now, gas packs down here, we're not doing any more package unit Evolution units, but there were a couple of them out there, older ones that might have been done in the past. But mainly we're focusing on the furnace, the heat pump, and a regular AC for the Evolution line. Setting up your thermostat. Let's go through that real quick. These two things, they both should be off. Double check on them. When you're doing the setup, this is the two screens that pop up for the thermostat. Make sure your smart recovery is off. Make sure your room occupancy sensor is off. On that Conex controller, there's a little tiny sensor on there. A lot of people don't know about it. And as I was telling Nick, if the thermostat's over here on the wall, but the living
Let
room's
me
over
bring
here.
thermostat from my truck, just to show guys where's the
Yeah.
sensor.
Yeah, go ahead and go grab one. Either way, if the controller's over here in the living room where the party's happening over here and nobody's walking up and down that hallway, if that room occupancy is on by accident and it doesn't sense any movement, it's going to shut the unit off. It won't work. Doesn't matter what programming you put on there. So honestly, that's why they send these now off, but just double check it, make sure it's off. Smart recovery, on or off. Make sure it's off as well, because it usually creates a problem. The smart recovery is that it starts to learn. That little sensor is this little guy right here. I mean, sometimes you'd almost think it's something to put a little magnet on there for the name of the company or whatever, but that's actually a little occupancy sensor. But make sure it's off. Smart recovery, I've also learned, make sure that's off. Smart recovery, what that is it'll start to learn that, okay, adaptive intelligent recovery is like what Honeywell calls it, or some other brands call it. All it means is, if to me, I wake up at 5 o'clock in the morning. So for me, I tell my thermostat at 4:45, start turning it on. I want a nice warm house. Okay. If the smart recovery is on, and you say maybe the homeowner wants the heater to come on at 5 a.m., it'll start to learn and it'll turn on at 3 o'clock in the morning. And some people, it'll wake them up. It knows that at 5 o'clock in the morning, you want 70 degrees, but it's 64 in the house. It's going to turn on in advance so that it's warm by the time they wake up. Some people hate it. Honestly, a lot of people hate it. They're like, why the hell is this thing coming on when I don't want it to come on until this time? Well, we turn Smart Recovery off and it takes care of that problem. Okay? Scheduling. This one company I used to work for, they sold the hell out of infinity units, which is the same as Evolution. You got a person doesn't understand scheduling or doesn't need scheduling. You can turn off scheduling and turn this into a manual thermostat. Heat, cool, or auto, and then temperature up and down. That's it. This is where you do it in the setup. I think it actually goes through all that here. Auto mode. So you can actually have it enabled or disabled. Auto mode basically means it'll show your heating and cooling set point all the time, and it automatically maintains those all the time through your programming. So you can enable it or disable it. That's what your little screen looks like. Simultaneous heat and cool. Leave it default off. It doesn't really apply too much to homes. I mean, most of this equipment goes in residential. I mean, if this was like a business where they're trying to get one office wants heat, one office wants cool, it could do that, and it kind of like, you know, flip-flops back and forth. But that could be off. It's not going to do anything. Leaving it off. And again, that's for zoning. I hardly ever run into that. Heat, cool, deadband. Okay, that's if I want heat at this point, cooling at this point. What's the closest temperature you can have it? You can do as little as 1 degree between the two. But be careful, too close together, you're going to be heat, cool, they could conflict. So that's why they show like a 3-degree deadband in between the heat and cooling set point for auto. Offsets. If your controller or your zone sensor or your little smart sensor is off by more than a couple degrees, you're going to have to replace it. It's going to get worse. Okay? But if you're uncalibrated the slightest amount by 1 degree, 2 degrees, you can go to the room sensor, or you can go to here, the desired offset, and adjust it by a little bit to correct that if it's a little bit off. But usually my experience, a thermostat, smart sensor, a remote sensor, whatever it is, once it starts being really crazy, more than a degree or 2 degrees off, it's there's something wrong with it. It's just the resistance value is starting to got corroded or whatever it may be. You're going to get a new controller, but that's where you can do your offsets there for your zoning sensors or your main controller. And if for whatever reason you need to reset factory defaults, you can reset the whole controller through there. Scheduling, again, if you want to have scheduling on or off. Smart recovery, trust me, leave it off. Okay, now we're going to get going into setting up the actual equipment itself. And we're going to start with the fan coil. And when you set up fan coil, it's going to give you these options here. Airflow, altitude, doesn't really have to do anything. Dehumidification, if you got to do anything with it, there's a few set points. And then the special G terminal. We'll discuss that here in a second because it's a neat little feature you can do with that. Airflow, you're going to see will breeze through the furnaces as well pretty quickly because airflow setup is the same. Heating, cooling, this is for a heat pump because of the fan coil. But if it's a furnace, you're gonna see it's pretty much the exact same thing. You have options of 300, 350, 325, max 400 CFM per ton. Everything comes default comfort, 350. If you ever start up a unit and you're like, man, I got a 22-degree split, but everything's perfect, that might be one you might want to reconsider. Instead of 350 CFM per ton, leave it at 400 CFM per ton. You guys out here closer to the ocean, maybe we get a little bit more humidity in these homes here than I do over in Modesto. Maybe you want to leave it at 350 CFM per ton. Less airflow, colder coil, more moisture adheres to it. You can dehumidify the house a little bit better in air conditioning mode. That's without even enabling dehumidification. But standard, when you do comfort, it allows for dehumidification overall anyways. So if you do enable dehumidification, you can actually tell it what to do.
Excuse me, can
Yeah.
we go back to the, so if we adjust airflow and we can choose between quiet, comfort and max, that means CFM per ton,
Yes.
right? Gotcha.
Yes. So whereas before you have the dip switches for the
Yeah.
CFM, plus a couple dip switches that go from 350 to 400 CFM per ton. So there's a couple. I mean, the simple way is with the dip switches. Again, a 5-ton furnace for a 3-ton unit. You don't have to do the 400 CFM per ton. You can just do dip switches to get that 1200 CFM.
Yeah. So in this case, if we adjust airflow to quiet mode, it decreases airflow to 300 per ton. Gotcha.
Yeah. So if you got a scenario where they're like, hey,
Yeah, let's do the
too
quiet,
much air. Yeah.
for example.
If you do this, anytime you do a setup, obviously check your charge, check your temperature split, make sure that too little airflow isn't going to create a problem for that compressor later on. Okay? You got, again, your dehumidification set points if you're using it. Yeah, honestly, I don't remember ever seeing this in the units, but this is just to help calibrate static pressure. I mean, I think they're going to come default to just fine for where you guys are at here for our elevation. Even where I'm at, it's fine where it's at. If you are doing dehumidification, you got to give that unit time to drain the water. If you're doing dehumidification, what this little smart evap does is it's going to force the unit to turn off. No airflow, no heat, no cool, nothing for 5 to 60 minutes. That gives that water time to come down off of that coil to drain out. Because if you turn on even the airflow, just fan only, as soon as you stop dehumidifying, if you turn the fan on again, all that air goes through that moisture right back in the house. That air will pick up that moisture again that's on that coil and throw the humidity right back into the home. So that's what this feature is for, is it gives it time to try to get that coil dried out as much as possible, let that water drain out. And you're going to see this option both in furnace and in a fan coil. Okay, G terminal shutdown. You guys ever install condensate pumps?
Yep.
Condensate pumps got a little safety switch. Okay? It's really easy on a regular furnace. You just break the R terminal, and that's how you set the safety switch. On the Connex, it's different. We don't want to shut anything down. We don't want to force error codes to happen that don't need to happen, but we want to know if the condensate pump isn't working. The G terminal shutdown does a few different things. Okay? A G terminal shutdown, or G terminal, does a fan, which means you got a steam humidifier that's going to throw steam into the room or into the ductwork, but it needs airflow. So you're going to use your own control because you want to use that control for that humidifier. That control just uses a dry relay. It's simply going to close R to G.
Wow.
Takes R to G together, and in this situation, when this fan, they're going to tell it what fan speed to do. You're going to enable it. You're going to tell it you want the fan to come on. You're going to turn the fan speed low, medium, or high. And then now you got steam coming into the house. I mean, humidity coming into the home. Or an ERV. An ERV needs ventilation, needs air to be flowing, needs the fan to be flowing. If your ERV control needs the fan to come on, it closes R to G, and that signals in this scenario, again, just turns the fan on. But condensate pump, now we want the unit to shut down. Or let's say you put this in an elderly home and you need global shutdown. You want everything to shut down, no airflow at all, for a safety, for a smoke detector, for a fire alarm, whatever it may be. Now you can use a shutdown feature or alert feature. And you can get that sucker to shut when they really shouldn't be turning that on. You can do the opposite. Besides not having low ambient coolant enabled, you can just tell it that if it gets to a certain temperature outside, never allow the outdoor unit to come on. Actually, that's a good one for, say it's a business and they're sharing a split system or whatever. You can actually, the owner of the building says, nope, no air conditioning, and once it gets this cold, you can do that for them as well. Defrost intervals, default is auto. Let the unit do it itself. You never have to mess with that. It'll work just fine all on its own. Again, low ambient coolant, if you turn it on, it won't harm anything. If they never use it, nothing ever goes wrong. Quiet shifter and defrost, all that's for is you guys know what a reverse sound sounds like. That whoosh, swishing sound. If that condenser is right next to the king and queen's house, bedroom, and it's loud and it's obnoxious for them, first of all, they should have paid you to move the unit anyways. But you can do what's called quiet shift. So instead of hearing a big old swish, it shuts the unit off for a little bit. It lets the pressures start to equalize a little more, and then it switches and goes in air conditioning mode to do the defrost. So that swishing sound is softer, it's quieter. Okay? If you run across that, that's what the quiet shift is for. Don't mess with this one. Again, this is like again, an example is if you're doing addition on the variable speed system and you want to make sure it doesn't go way too high because it's too big of a unit right now. You can adjust it, but again, usually you don't have to do anything with the variable speed stuff. Same thing, defrost delay, that helps out for that quiet mode. Brownout, it comes default off, you can leave it like that. Brownout is, if you ever drop below 187 volts, the equipment is not designed to work there. Your unit just won't work. And a brownout, that's what a brownout is. So a brownout could be faulty electrical from the street, it could be a faulty house breaker, whatever. Whatever causes a voltage to drop down below 187, that's a brownout. It's just a fault that tells you there's an electrical problem. It comes defaulted off. If you're out in the country, in the sticks, somewhere where maybe there is problems, you might want to enable it just so the homeowner knows that there's electrical issues. Otherwise, you can leave it off. This one you don't have to worry about at all. Reason being is, I mean, pretty much all these Bristol compressors on the older two-stage units, they're all gone. You can't even replace these Bristol compressors, they're like obsolete anymore. So default are Copeland compressors. Come defaulted for 80% of high is how it's set up. So airflow on low stage cooling will be 80% of high stage automatically with the Connex controller. It'll just do it all for you. And all this will be based off of your adjustments in regards to 350 or 400 CFM per ton. It will modulate the low cooling automatically for you with the Copeland 2-stage. Again, that's only for the variable speed stuff. Heat source lockout, sometimes you got to mess with this stuff, and this is just more or less for dual fuel. You know, at what point do I want my gas to turn on, at what point do I want my heat pump to turn on. Just kind of different set points there if you're doing dual fuel. This is where your defrost with gas heat comes into play, which if you're doing dual fuel you want to tell it yes, because you don't have electric heat strips for defrost. Latching, never have to worry about it. It's an option that's on there. There's probably some engineers say, hey, what if this scenario ever comes about? Latching is there, but very rarely do you ever have to use latching for variable speed equipment at all. Any kind of adjustment to zoning. If you got a problem, maybe some dampers are broken, and you got to replace dampers, you got to order them. You can disable zoning so just they all stay open, and all it does is works right off of the main controller. Any temperature offsets, airflow limits, and as well as you can do a duct assessment. when you can tell it when to do the duct assessment. Otherwise, it'll generally does a duct assessment every day about 1 p.m. Any accessories, if you're adding an accessory, if you want to, again, it's not controlling the filter, it's not controlling the humidifier. It will control that in regards to enabling the humidifier tab to work on the furnace or the fan coil, but it will not do anything else. It's a timer for the filter, it's a timer for the ultraviolet, a timer for the ventilator. Otherwise, we just kind of just entering in some information, so you can tell it, how often you want to change that filter. Same thing, it's even the humidifier. It's just whether you do or don't have one, and how often you get a reminder to change the humidifier pad. Oh, and humidify with fan, yes or no. You might have a certain kind of humidifier that doesn't need a fan, but UV lights, again, is just a reminder. Same thing, reminder for the ventilator. All those little setups there. Utility curtailment. Do you guys have service interrupters up here where they're rolling blackouts where they shut down the condenser at times? Okay,
No.
that is an option there. It's an evolution system. So again, just like a safety, we don't want to cut the communication line. We don't want to cut the low voltage or anything like that. But we want the outdoor unit to shut off. With the utility curtailment, basically. There is a little accessory, a little bit of wiring you do on the outside, just a quick little wiring to the outdoor unit. You enable it, and when it gets that signal from the electrical company to shut down the condenser for a little bit, it'll do it. It'll do it safely without any fault codes at all. So it is there as an option if you ever run across that. Again, if you're doing hydronic, you're setting up different accessories, so you gotta tell it how to do the airflow there if you do that. Checkout. This is where, on the maintenance, this is where I always teach my guys to go to here and to tell the AC to come on, keep it on so you go out there, check it out, and so on. Or if you want to just see why it faulted or whatever. So in the checkout, you see all the different modes that it can do. You can check out your zoning, you can test your zoning. You're going to turn on the electric heat strips with some airflow. This is a heat pump unit here, so you're going to turn on heating or cooling in the checkout mode. You can check your humidifier out, or even activate the ventilator if it actually could control a ventilator, because there are some ventilators that can be controlled off of a zone board, but we're not going to get too crazy into that one. But this is where you can check out all your different features of it. And it tells you your time. Same thing, checking out your furnace, low or high, or if it's modulating, it'll modulate on its own. Hydronic, same thing. You're just going to tell it how long you want the hydronic system to test for. And even the air conditioner. Again, all you're doing is forcing that unit to come on in that mode, so you can check it out. On the evolution, this is a trick question. Not too much of a trick. Let's see who might know it. A heat pump evolution unit. I think I gave the answer earlier. But at what temperature will it not work anymore? What outdoor temperature will it not let the heat pump heat anymore? Does anybody know?
70 degrees.
Close.
67?
Honestly, it's either 67 or 68 degrees. I think it's 68. They have a cutoff point. I get this phone call this time of year. Hey, Juan, dude, I'm trying to test the heat pump because I want to make sure everything's working. I want to go home. I can't get it to work. What's wrong with it? I'm like, did your air conditioner work? Yeah. How hot is it outside? Oh, it's 94 degrees out. Okay, so is this a heat pump? I mean, this is an evolution. Down below, underneath this little area, where all your electrical is at, underneath is your outdoor air thermistor, usually right here. You can usually just twist it off and pop it out. You twist it off, pop it out, throw it in ice water, and you can test your heater real quick. You're just going to trick it. You're going to tell it that it's 30-something degrees outside. But all of our heat pump units, even when you're trying to force it to come on, if it's above 68 degrees, it will not come on at all. Okay? If it's below 68 degrees, the heat pump will come on. You can test the heat pump. Otherwise, just trick it. Just put that thing in some water. Just cool it down. Get a cool rag that's been in water, that's damp. Wrap it. Get it nice and cold, and then it'll be a miracle to just come on for you. And that's the same. You guys do ductless as well?
Yep.
Ductless heat pump, same thing. It'll start like at 80 something degrees though. You gotta test it, the trick it, take the thermistor off of the back of the ductless, put it in ice water, same thing. Okay?
But if my condenser works good in the cooling, do I have to test heat pump? I mean heat pump heating in the summer.
This
Any
is-
reason to test it? Or
Just make sure it works.
okay, yeah, just
Yeah, it ain't gonna harm anything. It's not gonna blow it up or nothing. Because if you think about a regular old any brand heat pump unit, they got maybe outdoor thermistor, but most of them just got coil thermistor. They don't care. You get a regular Bryant heat pump unit. You put it, you activate the call for Y. It turns on the contactor default heat, right? It'll come on. Your pressure will be all crazy because it's really warm inside, really warm outside. Your pressure, your low side will be really higher than normal. Your high side will be higher than normal. That's okay. You're just testing. You're just going to make sure it works really, really quick. If you don't want to, you don't have to. If you turn on, theoretically, testing the air conditioner, that's going to tell us, the heat pump should work. All it is a reversing valve, right? A reversing valve and the fan on the variable speed stuff, but that's about it. So,
okay.
yeah, checkout mode again, you can check out all your different stuff, turn it on and off, ventilators, zoning. Okay, service information. This is important. When you go to service information, this is where you get to, you're doing a service call. If something's wrong, you want to see at least what's wrong. Find out what the error code is. Find out what the system is telling you. And, I hate this screen because of this geo heat pump status, but let's just say this is a fan coil status, a regular heat pump status, zoning status, and this one here is the important one. Last 10 system events. It's not error codes yet. The second page we'll see here in a second is. But the last 10 system events, you press it, and some of it might be information that it's giving you. Just like, hey, I had high static yesterday. Or I had high static earlier today. It's not a fault. It's just telling you this is what event we just had. If it is a fault in there, it would flat out say, maybe high static as just a notification, but it might also say high pressure trip, outdoor high pressure trip. Maybe those two go hand in hand because they tripped a high pressure because we don't have enough airflow through the indoor coil in the heat pump. But this is where you're going to find just your last 10 system events. It ain't a whole history, but usually if you're going there and something just recently happened a day or two ago, you're most likely going to see the last 10 system events. I've gone to several houses and looked at the last 10 system events and sometimes seen stuff that's like 5 or 6 years old on there. It just stores it. It's no big deal. Okay, again, your status. If the unit's running, you just want to see what it's doing. There's just some weird fake numbers that Bryant put on there as a display. Furnace, same thing, just the status of what it's doing, where it's at. If this is, again, these are just some make-believe numbers as if the unit's actually running. Same thing with zoning status, what the zones are doing. We know these numbers are fake because there's no way you're getting 8,000 CFM out of a unit. And again, this is right here. So besides the last 10 system events, run fault history. This is where you can actually find, it will show us here in a second, the actual faults for the heater, actual faults for the heat pump, actual real faults that are in there in memory. And then at that point you can actually delete them if you want, so you can actually have fresh data next time you come back. This I love, so I don't have to go outside. You select on this part, model numbers and serial numbers. I can actually get my control model number, serial number, furnace model number, serial number, and everything. If you changed out circuit board though, all that stuff's gone. If you change out the furnace circuit board or the outdoor circuit board, it'll tell you what it is, but it's not going to give you the serial number because it had that embedded in it when they made the equipment overall. But it's just a neat little feature to have. This is what your little last in system events would look like. Low pressure switch open, high pressure switch open. Again, these are just some stuff that they made up at Bryant. When I first looked at this, I'm like, this is weird. It's 1961 and 1962. Anywho, so let's say this is 2020 and this is 2021, it would look like that, if they were a year apart, whatever it may be. Run fault history, same thing. This is what the screen looks like. You're going to be able to go into the fan coil faults, and then you can look at the resettable faults. You can reset all that stuff. Where if it's a fan coil, furnace, or heat pump. And again, we just went through the model numbers, serial numbers. And if you want to have your phone number put up there, this is where you add the service phone number. Energy tracking only applies for the variable speed stuff. And charging. Again, as you can see, this is the older evolution, the 180, 280. 189, 288 is a 5-speed. 186, 284, that's the current evolution extreme. Refrigerant charging is only for the variable speed equipment. So once you select that, you can do charging by cooling, heating check charge. Again, this is where you should have already put what furnace, what coil you have. You're going to tell it the line set length, the suction line size, so it tells you how much total charge they have. So this right here, total charge, this means this much refrigerant along with what came with the condenser. Okay? Then you can actually select check the subcool on the unit. If it's, let me go back to this. Anytime you're in any of these screens, if something is grayed out like this, it means it is not an option for that unit. So whereas we were doing charging and cooling or refrigerant charging, if this was a standard 187 2-stage, this would be gray. You couldn't even get into it. Okay? So if it was an option, it would be highlighted in white like this, and you'd be able to select on it. Okay? Again, this is just some numbers of what it's talking about when you're weighing it in. The factory charge, how much you're adding. Now notice that this was nice. This is what you add for the line set. It says 12 ounces for the line set. But because of the high efficient indoor coil, it's saying to add 1 more pound to it. That's really important. If you ever do a startup, and it could just be a 16-SEER 1-stage unit, regular old Bryant, and you add the right amount of weight to it per the line set, and you start it up, you're like, what the hell? My subcool is only 4 degrees, or only 5 degrees, and this says I need 10 or 12. Sometimes it's because of the evac coil. So, not everything Bryant gives us is direct. Sometimes you have to be a nerd like me and have a lot of time on your hands to get behind the computer and just read a lot of different stuff for all the manuals, all the different things. And that's where you'll find out that I can't remember what manual, what book it is that Bryant has, but somewhere in there it actually talks about when you match up to certain evac coils, you will add 1 pound or 2 pounds more than whatever the system says, because it's a bigger indoor coil, more efficient, so the system needs more refrigerant overall.
So I never seen this line in a charge weighing. I mean, for indoor coil size, is it in?
Only for variable speed.
Yeah, I saw line set charging, factory charging, but never coil charging.
That should be, well, this screen right here,
Yeah.
they may have simplified it.
Yeah.
They may have
looks like-
simplified it to say add this much refrigerant total overall, but in order to get there, in order for it to tell you this number, anything right here, it needs to know this.
Yeah.
It needs to know the indoor coil and the line set size. It does the math and it tells you how much total refrigerant. I
Yeah.
think you're right. This is I think this might have been for the original Evolution Extreme. So now for like the new version of it, the
Yeah.
way they
Looks like
updated it,
just two.
it doesn't say add for indoor coil. It just says add this much more. But if you sit there and do the math yourself of the line set size, you're like, whoa, that's an extra
So I
pound or
don't
two.
need it if I have Evolution controller. Just put line set length.
It does all the math for you.
Yeah.
Yeah. Yeah, you
Much
can
better.
do it because you know, or if you use this feature, it's there. It's there. Refrigerant charging is there for this. So same thing as well, if you're going to do subcooling, it's going to tell you what your subcooling should be. And depending on your unit, like the Evolution Extreme does do subcooling, or like let's say this is the older versions of the 5-stage or the older Evolution, and you need to know you have 8.3 degrees subcool. Now you can go outside, hook up your gauges, Charge it to 8, make sure you're 8.3 degrees or around there, and then you're good to go. As you can see, it's just, in this mode, it's just doing it all on its own. Alright, pump down and evacuation. We're going to go through those here because if you ever got to do a repair, now a 2-stage evolution unit, you can push in the contactor, close the valve, push in the contactor, pump it down. Pretty simple. But there's no contactor here. Okay, we're taking single phase voltage, converting it to 3-phase AC signal to modulate that condenser, the compressor up and down. So there's no real way to do it, but oops, our controller can do it. If you got a, let's say you forgot to do a long line set solenoid, you want to trap all the refrigerant in the outdoor unit, you do a pump down. It'll pump down automatically for you. It does all the work, and then it'll pump down as far as it'll go, and then you close the valves off and you recover a pound or 2 pounds at the most. Makes the job a lot quicker. Instead of having to recover 15, 18 pounds of refrigerant, now you maybe only have to recover a couple pounds. So that's what the pump down feature is for. The evacuation, the variable speed stuff's got solenoids outside. It's got an electronic expansion valve outside. So if you ever had to do a repair, let's say whatever reason a line cracked, you got to repair the outdoor unit, and then you took all the refrigerant out, but you want to evacuate everything all evenly now. If you've got a variable speed unit, you need to tell it that you're evacuating the unit. That way it will open up all the electronic expansion valves inside that condenser. Okay? So your Evolution Extreme, like a 5 ton, you got a heat pump, a 5 ton, you got your electronic expansion valve for the metering device, and then you got your electronic expansion valve for the internal brazed plate heat exchanger itself. So evacuation, that opens up everything. That makes evacuation nice and easy so that no refrigerant gets trapped, so you don't shut it down and all of a sudden your pressure start rising up thinking you got a leak somewhere. Okay? And EXV position, I mean, you can get in there with a check on it and look at it, but honestly, you never have to really mess with this one, because if you're evacuating or you're pumping down, let the machine do its work on its own. The EXV is an electronic expansion valve. You can install a dealer logo. That's if you got something on the micro SD card, you're going to install that using this little feature here. Okay. You guys good to go? Or you guys want some water real quick before we go going? You guys good? Yeah.
May I answer one question?
Sure.
I have a question about if I install outside AC evolution unit without connects with Nest, how to do charging?
Just regular old subcool superheat. Yeah. So if you have an Evolution, so that you guys know, the Evolution Extreme, you can use a regular thermostat for high stage cooling only. It's labeled emergency. The Evolution Extreme is supposed to only work with the Connex. Okay, your 5-stage, 188, the 188 and 189, the 5-stage variable speed can use a 2-stage thermostat, a regular 2-stage thermostat. And a 187 can do 2-stage thermostat as well. But what you do is you just ask for high cooling. You tell it to go high cool. The furnace, you're going to do your dip switches to make sure it's high. And then you start up the unit and you just check your subcool. Realistically, on the variable speed stuff, still 10 degrees subcool is about the number. If you look at the nameplate on most of the units, it tells you indoor TXV subcooling, but on the variable speed, it doesn't tell you anything at all. So the only one that you can really charge that way is the 5-stage unit. But just stick to about 10 degree subcool, start it up, make sure it's in high cooling, you check your subcool, you got the right charge, then you check your superheat to make sure that indoor TXV is working okay, and then you're good to go.
Next question. I saw this plate in the unit. Installation prohibited in Southwest only. This is Evolution AC unit.
189 BMV?
Yeah. Why?
You different regulations. That's all about regulations throughout the country. Obviously, I don't have it on me, but if I have a map of the United States, the United States is broken up into different little areas. And so, like our area, the Northeast or Northwest, we're going to have different specs. We have to do different things for efficiency than other areas. We might be similar to a lot of them, but sometimes we may have more stricter regulations than, say, the people in New York do. So that's like on that uniform.
30 on 30 is very better side.
Well, Southwest, we're not the Southwest, we're okay. That 189 should be fine. So, what's that?
It will be what?
Yeah, it's a 3-ton. And so it's just a 3-ton, 5-stage evolution unit right there. So as long as you got it hooked up with the right furnace or the right, well, yeah, it's got to be with the right furnace on that, it'll work just fine.
Yeah, let's go forward.
Okay. So at this point, we're going to be going along through some of the stuff. This is definitely going to hit up on some of this stuff, and I'm going to breeze through the furnace. A lot of the furnaces is similar, but we want to definitely cover the major stuff on the furnace. That's the variable speed motor, the circuit board, and so on. Come on. Oh, that's why. You know what? My apology, guys.
Oh, no worries.
I forgot
So
to-
let's take 5 minutes break in this case.
No, I just forgot to plug in the power.
Oh.
It's almost dead. I knew I forgot to do something earlier.
Ну, у меня вот правый есть. Это же- да, манометр. Второй сказал, что
Вот
это
это.
какая-то... Да.
Она он средний говорит.
Ну, второй говорит, что это вообще какая штука, стоит кучу денег, и вообще все за тебя делает. Я так и не понял, что это.
Ну, нет, это понятно. Ты еще
Okay,
газ прощу.
Правый, да.
so we're going to start with the furnace and that troubleshooting guide. You guys all got copies of it. Again, besides carrying this in your truck, this is pretty darn cool with the the Service Tech app. There, as you can see, there isn't a lot of stuff on there. There are some neat little tips for a heat pump, but at least for the 987M, it does take you step by step. Just answer yes or no, and it helps you how to diagnose pressure switch, diagnose blower motor, diagnose inducer motor, whatever it may be. So first thing is, of course, I think we're talking about just make sure your airflows are all set up properly. Okay, so non-evolution, again, make sure your airflows are set up for each particular furnace, whatever you may have. Make sure you have the right set points and per each particular unit. So for instance, if you're doing a standard thermostat, okay, you want to go to the particular furnace that you have. So like this one here is a 42,000, 42, 60, 17 inch. So meaning that that's generally 3.5 tons, 60,000 BTUs of gas heat, 17-inch wide furnace. Pretty much the same, exact same over here in the 986. But the dip switch is configured a different airflow depending on your static. So just because, in a perfect world, we try to design stuff for half an inch of static. These numbers, when we're trying to design for half an inch of static, you got to remember, that usually means it's a furnace only. Anytime you put a coil on top of that air conditioner, you got more static is going to be added automatically. Automatically, you cannot get away from it. A fan coil like what we have over here, there's no heat exchanger, there's no primary, there's no secondary, there's nothing in the way. So the statics on these are always going to be a lot easier to get to. They're a lot lower on these than it will be on the furnace, because a furnace, a high efficient furnace, you got your blower motor, you got your secondary heat exchanger that looks like a radiator, then you got your primary heat exchangers, then on top of that you're sitting your indoor coil. So more static on top of more static on top of more static. Whenever you do check static on a furnace, to find out if you're getting the right airflow. Return is return. So put it underneath, put it on the side, whatever, somewhere where it's measuring a good amount of return air. So if this was a box, a metal plenum right here, it'd be perfect, right underneath. That's your return, that's easy, okay? It's going to be a negative number. because it's a return side. Now comes the pain in the butt part. You got your coil sitting right here. Supply's gonna be right up there. A lot of people make the mistake and they go return, supply, that's my static. Oh, perfect. I got 0.4 static. Look at my airflow. I got 1,255 CFM or whatever it is. I'm good to go. I got what I need. But these numbers are external static of the furnace. So now the challenge is you got to figure out how to get in here on this evolution unit. On the evolution unit, being that it's a constant airflow motor, from no static to a little bit of static is not a big number. Look, very little static, 1240, 1190, 50 CFM. That's high static. Look at 1 inch of static, 1115. That's 100 CFM, 120, 130 CFM. Not a lot. If you look at these numbers for a standard, say, 911 furnace, 912 furnace, 915 furnace kind of deal, the ones that have those X13 5-speed motors, and you look at the difference between 0.2 static or 0.1 static and 1 inch of static, several hundred CFM difference. This is what makes a ECM, constant airflow evolution furnace awesome. Okay? So again, just make sure you see how the numbers are pretty close. So whatever you're doing, like this is a 3.5 ton capable furnace. If you put a 2-ton air conditioner, you can still do it. Make sure you're adjusting your dip switches so that you're getting your 800 CFM. So that it works, so that this furnace will work with a 2-ton unit, for instance. If you put in a Connex controller, automatic. It will automatically do it for you. Now for a 2-ton unit, maybe a 5-ton furnace may not work. So there does come a time that there's mismatched equipment. But if it does work, I mean, hell, look at this. This thing can go all the way down. All the way down to 500 CFM. So there's a lot of things that that thing can do overall. And again, you don't have to worry about the 830C. The 880, again, it's still, it's a 80% furnace. It's still variable speed, constant airflow. Okay, where are we going on? Each one has its own diagnostic. So you could go to the Connex controller, or you can go directly to the furnace, and you're going to look at and see what it's flashing. All of them read the exact same way when you're looking at the error code. Each status code is a 2-digit number. The first number is by the short flashes, and the second number is the long flashes. Okay? There's still, with trying to get done here in time, there's a lot. I mean, you can see just even the 987M, there's a lot we can go over. So let me leave it up to Nick. You tell me.
Yep.
What is it you see that you think is the most important we should go over on the 987, the modulating furnace? Oh, by the way, notice how I gave you a manual for the 987. There is no manual. They didn't come up with a manual for 986.
Mm-hmm.
There's no manual for an 880 or even our 830. But here's the trick. Pretty much same blower motor. The 987, a major difference here is the ECM inducer motor. It is an ECM inducer motor because of that modulating furnace. The other ones are 2-stage. That's the only difference. So it's just going to be a lot easier to diagnose in regards to low fire rate or high fire rate for the inducer motor. But the blower motor, you can take the knowledge of that 987M manual I gave you. If you're thinking of having a problem with the blower motor or one of the other models, you can use it. It'll help you through how to diagnose that. So, step by step, pressure switches. Let me do it this way. You think it's furnace that maybe we should go over first, or do you want to go over air conditioners?
Furnace.
Furnace? Okay. All right. So, first one we're going to go over step by step. I think I went too far. Let me start right here. I wanted to go over what a lot of furnaces share in common overall. So let me start with this one right here. And in the error code, number 11. If you're doing a status recall, all the units got a way to do a status recall. It's switch number 1. SW1 number 1. There's 8 switches, and the very first one, you flip it on, and all you're doing is telling that circuit board, hey, can you tell me what faults you've had? Again, this is without using the conics. All right, this is without using the conics, because you're just at the furnace, you're up in the attic, and I know what it's like to go up and down a freaking ladder going in and out of an attic. So I'm not going to go up. I'm not going to go down. I'm just going to flip that switch and see what the past error codes are, because the complaint was no heat, right? Number 11, no previous fault code just means, well, crap, there's no previous fault code in there. It will save the stuff on there. It'll save it up for up to 72 hours, okay? So if there's no previous code, maybe you just weren't able to make it. Maybe you guys were so swamped that it's been a week since the last time it faulted, and you're just going to have to start it and run it and see what happens. 12, they all share 12. Basically, blower on after power up. So that means you got to call for heat, and you open up the door, you're looking at seeing what's going on, you're checking it out, you close the door, and all of a sudden it starts flashing. And it's a 12. Well, that's because the thermostat was already asking for heat. So as soon as that unit came with power, R to W was closed, or R to W1, W2, whatever, they were closed. And it's just going to turn on the blower motor and cool down the heat exchanger, just in case there was a power outage. So let's say your unit's running, and PG&E has a power outage for, hell, 10 seconds, whatever it is. Even if it just shuts off for like 5 seconds, 10 seconds, the unit shuts off and comes right back on, that heat exchanger is hot. So because it sensed that it was asking for heat immediately, as a safety measure, instead of turning on the burners again for 30, 40 seconds before the blower turns on, it purges first for 90 seconds and then allows the heater to turn back on again. Okay, limit circuit lockout. Actually, that's going to be 33 first. We're going to come back to that one. Let's look at pressure switches. I think I got some schematics here for a pressure switch. So we're going to go from number 12. We're going to skip back and come back to these other ones because 13 and 33 go hand in hand. Before I go to 23, 24. They all share 24. Just means the fuse is open. On the circuit board, that little 3 amp fuse or 5 amp fuse, 24 just means the fuse is open. Pull the fuse out. Is it good? No? Put another fuse in there. Be ready for more fuses. If you don't already carry fuses, you should always carry fuses. Honestly, I've shorted out more fuses than I found bad fuses, okay? Yeah. Most of the time, I create the problem, okay? My finger slips, my screwdriver slips, my jumper wire slips, I'm up there jumping it, the flip wire goes sheet metal, I'm like, I swear to God, you'll probably run across some of my jobs, you never will, but some people have run across my jobs, and there's a freaking little thermostat wire right there on the fuse, because guess what, I ran out of fuses. But, so you gotta do what you gotta do sometimes. Anyway, so that one is shared, 24. 25. This is a heavy ass thing to show. Do you guys know what a model plug is? It's not very common. Most of you guys do install? Or service?
Yeah, most of us is installers.
Most installers, okay. Well, just so you know, this has happened on a brand new unit. Accidentally, from the factory, it just fell out. So, on this board, I want you guys to point out to each other that little black thing right here. It's got 4 little holes in it. It's a little if you can show the guys right behind you, that little bugger right there. Okay, it's a little small chip. It's no relay or nothing. It's got a couple resistors on there. It's like 3/4 inches by 3/4 inches. It's really, really, really easy to miss. For service work, guys have replaced the circuit board, put the new board in it, and they get a 25 because they didn't take that little model chip from the old board and put it on the new one.
Oh.
On a brand new unit, if you get a 25, it's going to be for a couple reasons, as you can see here in a second.
Yeah, I had this like just 3 days ago. And
I found that I need to change, like, take the chip, like, from the old board.
Yeah.
Yeah.
Well, sometimes
I didn't know about it. Yeah.
it fits on there well, but there's been like one or two. There's been a couple little weird ones where it fell off, and it's sitting on the bottom of the furnace. On a brand new unit, they get a code 25, and that little chip is missing. Now it just fell down. So just that little chip's got to be in there. Okay. So yeah, if you replace one board,
Yeah.
make sure you swap that chip. Now, other reason is this right here.
Я тоже не поставил, блин.
SW1 number 6. Okay, on a furnace, SW1 number 6 is on, or SW1 number 1 is on. If you're looking for past error codes, you flip it on, you look for error codes. As soon as you do that, flip it off. If you leave it on and then ask for heat, you're going to get a 25. You got to make sure number 1 stays off after you look up your error code. Now, number 6 on a furnace is a testing switch. When you flip on number 6, it goes through a testing procedure. It will automatically turn on your inducer motor, hot surface igniter, blower motor, and then shut down. After you do that, and on the 987M furnace, it tells you to do number 6 switch on as part of the testing to look for voltages to find out if it's a bad board or a bad inducer module. After you figure out, yep, I got a bad board, or yep, I got a bad inducer motor, don't forget to turn this off. Because every winter I get a phone call, hey, Juan, remember last week or yesterday you said that we got to replace this inducer motor? Yeah. Well, dude, now it's giving me this fault code. I'm like, did you change the model's chip? I didn't change that. Okay, then go look at your dip switch number 6. If you leave the 6 on because you're doing the testing procedure, after you're done diagnosing your unit, shut it off. Because if you accidentally leave it on and you ask for heat, it'll give you a fault and nothing will work. So number 1 being on, SW1 number 1 on, or SW1 number 6 on, if you leave them on by accident, it will not work at all. And it'll give you a fault code. Okay? So,
If we have 25 error, that means we need to turn, like, to make it off both of them.
yeah, just make sure SW1 1 is off
Mm-hmm.
and SW1 number 6 is off.
Okay.
As long as those two are off, the model chip is in there, you shouldn't get a 25.
Okay.
I gotta find, I think it's gonna be in my schematic, but that little model chip is just some resistors. The resistors basically tell the furnace what size it is. That's it. Those resistors very, very rarely ever go out. If you get a code 25, it just simply, there's 4 connection points. On the door of the unit, it actually tell you, you can call us, I don't have it off of memory, but you check two connections, you look for a certain resistance, and you look at the other 2 connections, look for a certain resistance. If you don't have that resistance, then that little chip is bad. Very rarely does that happen. You check the resistance and everything looks okay, and your furnace board is still giving you a 25, and you got these switches off,
Mm-hmm.
something's wrong with that board. You just have to replace the board. Okay? Usually, 99% of the time, the 25 is because we forgot to put the little model chip back in there. Okay? 22, you'll find that everywhere. Abnormal flame proving signal. Flame is proved while a gas valve is de-energized. What that means is the flame sensor or the board is receiving micro voltage stating that there's a flame there. But I don't want heat on. I just turned the heater off. The board is thinking it should be off, but it's sensing a flame there. So all you got to do is go look at it. If the gas valve is leaking gas through and is keeping the flame on a little bit longer, it means replace the gas valve. If there is no flame there, you do the traditional clean up the flame sensor and all that. Make sure the flame sensor isn't dirty or corroded or nothing. And then if it continues to do it, it just means there's something wrong with the circuit board as well at that point. So it can only be a few things. The abnormal flame proving, if there is no flame there, there is nothing wrong with the flame sensor, you replace that. I think it's the next page. Yeah, these are going to go hand in hand in regards to the ignition proving. So 34, ignition proving fault. They all have the same thing. The most common thing is just it's not sensing the flame, either because dirty flame sensor, bad board, or the gas valve isn't even opening up. There's no flame at all. In the many years that I've been doing this, I've replaced one flame sensor. One. That's it. 17 years, I found one flame sensor I replaced. And it was still working. It was on a propane unit, and for whatever reason, the propane, it creates some kind of little chemical reaction with the atmosphere. It was eating away at the flame sensor. Where I'm getting at here is, very rarely, when you got a system that's not sensing a flame, and you can see a flame come on, and you can see the flame hitting that flame sensor, I've never had a faulty flame sensor. I get a lot of people call me and say, hey, I already replaced the flame sensor and I still get a flame fault. Well, it's probably not your flame sensor then. Usually it's, maybe there's something wrong with the wire. So the wire that connects onto your flame sensor, this white wire right here. This white wire, as you can see, it starts up here at the furnace, or if you turn it around, doesn't matter. Starts right up here at the burner compartment. It goes through your sheet metal down into your board. And it actually plugs in, to the multi-pin adapter right here on this connection point. So, a lot can still go wrong with the wire between here and there. Okay? The wire could be damaged. So sometimes you got to look over here as it penetrates through the sheet metal. You got to look at it, make sure. Sometimes the zip tie got on there so tight, or if it's zipped on somewhere else, it's zipped on so tight that that zip tie actually kind of cut away at that metal or at the plastic. And suddenly you got it making contact with metal or making contact with something else. And that could be the problem. Okay? But usually the most common thing, it gives you numbers right here. Your flame sensor can work for as little as 5 microamps DC. But normal voltage that that thing is generating is 4 to 6 volts microamps DC overall. So to check it, unplug, put 1 meter here, the other lead right there, turn it on, and you read your microvoltage. If your microvoltage is reading, which most likely will, after you clean it up, a lot of times it's just a dirty flame sensor, but once you clean it up, if you're reading the right voltage, and your wire is not damaged, just confirm there's nothing wrong with the wire between up there and down below. If there's nothing wrong with the wire, then it's a board. It just means that the board is receiving its signal, but the board is too stupid to know that it's working right, and it'll not let it work. And it'll tell you ignition proven failure. Okay? So on 34, again, that's why it tells you the very, very, very first thing it says is oxide built up on the flame sensor. They talk about steel wool, whatever. Man, I've grabbed my brazing kit, taken sandpaper off of there, cleaned up the flame sensor, put it back in there for 17 years, and it works fine. It works just fine. So again, if there's no flame there, then you look for voltage. Okay, so here's our flame sensor circuit. Ground wire on the gas valve, real important as well. First, the other major thing for sensing a flame, where'd it go? Green, yellow wire must be connected to furnace sheet metal. Your gas valve needs to be grounded. Not so much that, but you have to have a good ground from the home. The home has to have a good ground for your appliance plug, whatever you're using. Your furnace has to have a good ground. If your furnace ground is faulty, your flame proving will be affected. It won't sense a flame that easily, and you'll have a problem. So, flame sensor must not be grounded. That little rod, as it bends in, maybe by accident at the factory or whatever, it got bent and it's touching metal. Make sure it's not touching metal. The wire, again, make sure it's not touching metal. Otherwise, that's going to affect it. Hot surface igniter. Obviously, if you got flame there, it means the hot surface igniter works. So, if your gas valve is on but no hot surface igniter, you got to see if the hot surface igniter is getting power. And again, control ground continuity. You got to make sure you have a really good ground. This one was an easy one. I don't know. When I first started doing this line of work, I worked for a company. We did a lot of tract homes. Oh my God, how many calls I did time after time, especially on a Saturday, where I jump up in an attic on a brand new house and the heater doesn't work, and all I had to do is turn the gas valve on. Just make sure your gas valve is, ball valve is on, little flip the switch on. That'll tell your gas. Because what'll happen is, a lot of times we don't even think about this stuff during the summer. Right? Who cares about the heat during it's 120 degrees in the attic. Do I give a crap about the heat? Not really. But again, just make sure that kind of stuff is on. This is why you're asking me about the heat pump. Same thing with the heater. Why turn on the heater during the summertime? To make sure. Because it works. Because I want to tell that customer, I want my money now, man. Your heater works, your air conditioner works, give me my money. So, okay, so your electrical circuit over here. These are the 4 different types of systems that we have. Modulating, 2-stage, and so on. This is your modulating gas valve. This is your 2-stage. The other versions of the 2-stage, and I think this is actually which gas valve is that? That's just a single stage. This is for the unit you guys won't run across, that ultra low NOx furnace. But they all got a flame sensor that connects onto the CPU to the computer. Again, all of the gas valves got to make sure that they're grounded. Again, it doesn't show the high voltage side because this is a 24 volt circuit of it. Make sure it's got a good ground. So to make sure you got a good ground, I simply would just go sheet metal to L1, and if I got 120, I'm working. And that means I should have a good ground overall, okay? If I don't have it, or like low voltage, if I only have like 60 volts, 70 volts, I better check out my outlet. Maybe the outlet's my problem, why I'm not sensing the flame. So, anytime you check 120, a hot leg to neutral, 115, 120, a hot leg to ground, 115, 120. That's how you just confirm that your ground should be good.
Excuse me.
Yeah.
One question about ground. Usually in electrical panel we had jumper between neutral and the ground in the furnace. Has this jumper too or no?
No, it's so.
Because old unit don't have ground wire, only phase and neutral. No high efficiency. Only 2 wire connection.
On the high efficiency units,
Yeah.
the ground wire is connected to the sheet metal.
Yeah, in high efficiency units there are 3 wires, ground, neutral and phase.
Right.
But in simple units, just 2 wires, neutral and phase. I mean, no ground wire. It just
It should
just
have a
terminal.
green wire in the sheet metal. Which unit are you referring to? Which model?
All of the units.
All like a regular.
Yeah. So high efficiency has 3 wires,
Uh
but the simple units 1 and
Oh, you mean like an 80% furnace?
yeah.
I'll look at that here in a second, but I'm pretty sure they all need a good ground, or they will not. So
No,
On
they
s-
have just terminal, not the wire. That's our question.
what do you mean?
I mean, just terminal on the plate, metal plate of the unit.
Yeah.
Yeah, and they don't have green wire. And they were asking
Oh.
about the.
So I see what you're saying. So in here, in this little box right in here, where the electrical would come in on, there's a green wire that's connected on the sheet metal, and then there's a white wire and a black wire that goes to the board. So you're saying that on the 80%ers, there's no green wire coming out?
Yes.
Yeah, you just attach it on the sheet metal.
Yeah.
Yeah. So
Okay.
when you look at that, that's how come. Okay. So for flame sensing, like I think this is your 80% 2-stage, and this is your ultra low NOx furnace here. See, you got this symbol right here is ground, earth ground right there. So that's where it's getting its ground from. You can't see it. I'll pull up. I think it's gonna still show me, or I'll pull it up here in a minute. When you look at your 24 volt circuit up in here, you got your section 1, which is your hot leg, and then your section 2. As soon as this touches metal right here,
Oh yeah.
that grounds out the transformer already as well. So that's how come as soon as you go the ground wire from your appliance cord and just screw it into your sheet metal of the unit, it grounds out the rest of the unit. So the high efficient, there's a little more to it, which is why it's got a separate ground wire. It wants to protect, you know, the ECM and the blower, both of the ECMs or both of the inducer motors and the ECM motor. So it does have a different, bigger ground wire connection to it overall.
Gotcha.
But yeah, even those, like I said, it's, if we open this up, where's my connections? You got 3 wires right here, but if you fold it all, it just goes right here, sheet metal.
Oh,
Yeah.
pretty simple.
So if you don't connect anything on here and just screw it into the sheet metal, same thing.
Good to know.
Yeah, it'll be the same purpose. Sorry, was that what that's what you were asking? Okay. So no flame. It's a little difficult on the modulating furnace is pretty easy. In that manual kind of talks you through a little bit of DC voltage to look for that tells you that the circuit board is working fine to activate that gas valve. I've never had a bad gas valve overall. Maybe this is my good luck, but the modulating gas valves I've had good luck with. The 2-stage gas valves are easy. When you're looking, you got a common, and then you have low stage and high stage. So when it's a common, put your meter on there, common to low stage, 24 volts, yeah. Is it opening up? No. Bad gas valve. Okay? But as you can see, this voltage comes from the circuit board. So even though it goes in series with a high pressure switch, that's for pressure switch proving. So no matter what, your flame should come on. Common to high or common to low first, and then common to high. So you got common to low, you got 24 volts and the gas valve won't open, you got a bad gas valve. On this one over here, it's just a hot and common. On the ultra low NOx, which you're not going to deal with, but it's either open or it's not open. And then 2-stage over here, same thing as this 2-stage there, where it's common to low and then common to high. So you just got to confirm if it's getting voltage and the gas valve won't open, it's a faulty gas valve. So some pressure switches here we're going to go over because they all share a lot of the commonality. Your 986 and your 880T are going to be kind of pretty similar because they're 2-stage furnaces with 2 pressure switches in there. Actually, you got 3. Sorry. Then you got your different pressure switches. I'm confusing myself. I apologize. It's only 2 pressure switches. This is your low gas pressure switch, if it's even used. Okay, it's your low pressure switch and your high pressure switch. Then on the modulating gas valve, the low gas pressure switch is optional. So there's 3 pressure switches on that one. Low gas pressure switch is optional. Low pressure, high pressure here. And we're not going to worry about this because it's a transducer. That's an ultra low NOx unit. So we're going to talk through when you got a problem with one of those switches, what to look for on pressure switches itself. On a high efficient furnace, evolution or non-evolution, the most common thing that will cause a pressure switch to not close, to not work properly, is water, moisture. Okay? And moisture is going to happen, usually not right away, it'll happen later. And a lot of the times that happens when we don't do the condensate drain right. When our condensate drain is not hooked up properly, the unit's not draining out properly, it's going to collect water in there. Water makes its way into the tubing. It stops the pressure, it stops the unit from working. And sometimes that water, because it's warm, because it was hot in there, could actually migrate up into the pressure switch and then ruin the internals of the pressure switch even after you fix the condensate drain. So just be careful on that one. But again, like in this situation, this is your connection is up here. Obviously this furnace at one point was set up to be a downflow. So yeah, if we turn this on right now, try to run it in the upflow configuration, downflow condensate water, it would fill up and then it would not work. Okay, so let's look at what's going to cause what to look for here. Medium 31. This is on the 987M. Medium pressure switch, high pressure switch, or a PSR relay did not close or reopen. So pressure switches, like this one right here, there's 2 of them right side by side. If they stick, That's simple. You're just gonna check continuity. So if the inducer motor is off and we think that you're getting a fault because a switch is closed, you're checking for 24 volts. So this is easy because we got a furnace to go over, but you can go sheet metal because of the grounded wire. A lot of times I go sheet metal, I'll put my probe in here in the sheet metal. You check one point, I got 24 volts. You check the other point, I got 24 volts. My inducer's off. My pressure switch is closed. It shouldn't be. My pressure switch is faulty. You can undo the hose. Or I should have, oops. I kept pressing this thing. What we're looking for did not reopen, means that that switch is closed. So that's what we're going to check. All right. Now, second, the other one is pressure switch did not close. And this is both the medium, the low pressure, or high heat pressure switch. Didn't open or didn't close. You check for power on the switches to see if it's already closed or not. You can unplug them carefully, check continuity. If they're closed, it means a faulty switch or not. But didn't close. That's the most common thing. Something's wrong, my inducer is running, and my switch isn't closing, or my electrical doesn't flow from one spot to the other. You have to get up for 1 second. Let me show you something really, really quick. At least on these furnaces, it's pretty convenient. All these pressure switches have a rating on them. So look at this one right here. It has negative 0.68 PF. What that means is point of failure. Every one of these pressure switches is going to have a different rating of PF of what it'll fail at. Now they're making these easier compared to the older ones. They're flat out telling you negative 0.68 PF is point of failure. You're going to add 0.15 more to that. So 0.68 plus 0.15 means 0.83. This switch will not close unless the pressure is negative 0.83 or higher. If the pressure then closes and then the switch drops below 0.68, then it opens. Okay? So this is where manometer comes into play. Okay? And I don't want to go back to the picture, but the UEI, it's got the T. Okay? The little T is for this. This is reading pressure up here. So you're going to plug this into the T or just plug it into your meter. You can do it either way, depending on how you want to do it. If you want to have this try to run at the same time, either way you put your manometer in here, you turn on the unit, and you're looking for 0.68 plus 0.15 more. So I'm looking at least negative 0.83 inches of water column or more. If I got, say, 1 point whatever inches of water column, and it stays steady, and I plug it in, and it still doesn't close the switch, it's a faulty switch. So that's what you're looking at. The other thing you want to look at is you can bypass this, trick it to come on, or use the little T's that come with the UEI. So you put your little T in here, put manometer there, a little short piece of pipe right in there, so don't forget. And the unit comes on, and the unit starts running. And then 5 minutes later, it turns off. Where you can be watching your pressure. If your pressure goes from like 1 inch of static, and it's dropping and dropping and dropping and dropping and dropping and dropping and dropping, and then it shuts off. It's below 0.68. Something's happening, and it's not allowing negative pressure to build up in here. You can take this out. Is there water in there? Is my inducer having a problem? Do I hear gurgling? Do I hear something going on? A lot of times you're going to find you got water in here. Maybe your P-trap is clogged up, or just the drain line is clogged up. I mean, you'd be surprised. A lot of times just a flat-out condensate drain that goes outside is clogged up. Somebody ran it down into the dirt, too much into the dirt, because the homeowner wanted to make sure it goes in the dirt, and stuff splashed up from the air conditioning season and clogged it up. And now all this is filled up with water. And so because of that, the pressure keeps dropping until it turns off. So that's how you look. Any one of these switches is the exact same way. You can't see it, but if we take this off on the back side of this other switch, it's going to give you the same exact readings. Okay? The 987M, it's awesome. The modulating furnace, it talks you through everything in that manual. Or on the Bryant Service Tech app, same thing. It'll talk you through what to check for, what to look at, and so on when one of those pressure switches isn't working. But it doesn't matter. So here's your pressure switch. It doesn't matter if it's a single stage 80% non-evolution or single stage a non-evolution 90%. The pressure switches all work the exact same way. They close on a negative pressure. Okay? So you can see this little symbol right here. So this is like a high pressure switch. So it works a little bit different on this unit, but this is, I'm sorry, this both these are the same. It's this one that I confused myself on. This one here opens when pressure drops. This is a safety switch for the low gas pressure. When you do an LP kit, there's a little gas pressure thing that you put on there in the little T or with the little adapters, that if your propane pressure drops too low, it opens up. This symbol means that this switch opens with pressure drop. This switch is always open, and it means it closes when pressure drops. That's fine, it's supposed to close. When negative pressure is applied to this switch, it closes. And that's what those switches do. When there's enough negative pressure, that's what it says, negative 0.68 PF, point of failure, negative 0.68 plus a 0.15 more on it. When it reaches that negative pressure, it closes that switch and it stays closed. As long as that negative pressure is always there. So it'll open on pressure rise over here. This means it'll open on pressure rise. This one means it'll open on pressure fall. So these switches, all this means overall, it is a defaulted open switch. This safety switch or these pressure switches, they're always open until pressure is applied to it. Positive gas pressure closes that safety switch. Negative pressure in the inducer assembly closes that safety switch and allows the heater itself to work. All of them. See this little section here, which are the 987M. This little section for the 986 and the 880T are about pretty much the exact same thing. Simple and to the point. If your flue is good, always confirm your flue is good. Confirm that no water is getting into the inducer motor. You'll hear a little bit of splashing sometimes will happen because as a collector box cools off or as the inducer motor cools off, a little bit of moisture is in there. Not a lot. But this little piece here, I can't even tell. This isn't the piece. This is your this is the new design of our inducer assemblies. Notice that you got an inner pipe and then an outside section.
Yep.
Okay? The previous model of Carrier Bryant units had a condensate drain on the inducer motor. There was a drain on the inducer motor itself and it would drain out the water. Now this new design with the inner and outer, it's basically designed so that, because you can stub this straight up, water can get in there up on the roof. So the PVC pipes up there, water can get in there. Plus, even at that, no matter what, once it shuts off, even if you got a 90 all the way down, no water is going to get in there. But as the flue gases are leaving, there's moisture in there. And when it shuts off, it's going to cool off and condense and then continue to drain down. So when it drains down, it goes on the outside and then into the collector box. So it will, if it goes in the middle, it goes to the blower motor, which it won't. This whole little design system here is set to when it shuts off, water goes on the outside. It won't go into the inducer motor. It goes to this back piece right here. It drains down and then it'll drain out through your collector box itself.
Makes sense.
Okay? That's how come you look at that and like, hey, water's gonna get in there. Is that a problem? Not really. It'll drain out just fine. Okay? But when it comes to pressure switches, as long as you got everything wired up, connected properly. For instance, well, this was done right, but usually water's just not draining. Water's not draining. On very rare occasion, and we're talking the big units, the 100,000, 120,000 BTU units. I had a couple this last year, 120,000 BTU units, and they put 2-inch flue pipe on it. Can't do it. Had another one that was a 100,000 BTU unit. They put 2-inch pipe on it. It's okay, it's allowed, but they're at 6,000 feet of elevation. You can only do like 5 feet or something like that. Once they changed it out to the right flue pipe, the thing worked beautifully. No more intermittent issues. But pressure switches, a manometer to make sure you're registering proper negative pressure. If you're not sensing proper negative pressure, or that pressure goes from like -1 inch and it's dropping and dropping and dropping, look at your water, find out what's going on. Now, either you're going to hear your inducer motor slowing down because there's a problem with the inducer motor, or maybe there's a, because I've run across this, a dead bird in the flue. All right, I've had dead critters in flues, whatever could be blocking the flue. It ain't necessarily that we install the flue wrong. Sometimes, especially after it's been installed for a while, something's in there. Usually on startup, everything is fine. The most common thing on startup for you guys that I see, people overlooked it, didn't pay attention, that yellow and black wire, or yellow and black tubing. The black, that's for your pressure switch. Yellow attaches onto your P-trap, and it's just an extra vent. It's just venting some of the pressure a little bit out of the drainage overall. Okay? I had one guy that swapped these by accident. So his pressure switch would never close because it was never hooked up to the collector box. It was hooked up to the condensate drain instead. So once he sent me a picture and he flopped it over, the thing, it was a miracle. It started working just fine. But for install, that's a very common thing. Every time you change it around, upflow, downflow, upflow comes fine right out of the factory, but horizontal right, horizontal left, or downflow, you have to change the stuff, and sometimes we just put them in the wrong spot, and it just happens. So when it comes to pressure switches, especially for you guys, again, on startup, usually something's just disconnected. It's just in the wrong spot. On a rare occasion, it's a faulty switch from the factory. But again, that's where a manometer comes into play. You confirm you got the right pressure. You confirm that the switch is not closing, and you're good to go. But if your switch shows continuity, but your board is still registering a faulty pressure switch, you got to watch your wiring. So let's look at a simple one like this here. You got power goes, low pressure switch, and back here to this connection point. There is no low gas pressure switch in this scenario. But then for your high pressure switch, it goes to the gas valve, to the pressure switch, back to the board. Just reconfirm that there's nothing wrong with the wiring. So since we got a unit here, if you guys want to come over here one more time real quick. Come and look at these connections here. Every little wire has its own little terminal, and it's got its own little connection there. These little pins, these connectors, they have to be made, right? So this little white piece just comes like probably in the thousands and thousands in the box. They take the wires, and you can't really see it, but once they actually attach the wire onto this little terminal thing right here, they just start sliding them into each little spot, and then it creates this plug. On occasion, it slides in there, the little thing that clips in there broke off or doesn't make good contact, or wasn't pushed in all the way. And the problem is that the wire is pulled out a little bit, and it's not making contact to your board. So, process of elimination for, say, a pressure switch fault. I have 24 volts here, 24 volts here, 24 volts everywhere. I'm following my schematic and following power coming back. I confirm that I got power everywhere. I confirm that my connections are good. For instance, I can look at here and check continuity between a couple points and show that the circuit is complete before the high pressure switch and is complete on the low pressure switch. As long as I confirm all that's good, I plug it in, all the pins aren't damaged or nothing. It does sometimes happen. It could just be a faulty brand new unit circuit board, unfortunately. It does happen sometimes, but that's how you're gonna determine, is it a bad switch? Is it not connected to the right spot? Is there something wrong with my inducer motor? Something wrong with my wiring? Or something wrong with my circuit board overall? Okay, so that's pretty much it on pressure switches. Before we move on to some of the other stuff, any more questions on pressure switches? Because I'm actually running out of time. We got about another 10-15 more minutes.
No?
This is, well, it's only because it's a service manual. If you look at your service manual on the back of your 987, if you can't read the numbers on the pressure switch on the modulating furnace, this actually tells you your break point and your make point. You can kind of see the difference, you know, in the BTUs on what they make and what they break at. But either way, your high pressure switch, medium pressure switch, low pressure switch, you still see the difference is 0.15. So I would say between 0.15 to 0.2 above that PF level, that switch needs to close. If that switch does not close 0.15 to 0.2 above it, and your pressure is above those numbers and the switch is open, then that switch is faulty and needs to be replaced. And just some live pictures I took of the equipment showing those pressure switches. These are just on the blower motors. Again, I use the same blower motor, same inducer motor. You will definitely, I haven't had a single blower motor or a single inducer motor, and I hope it doesn't bite me in the ass here, but on fresh startup, I have had not a single one of those ever be bad out of the box on a 987. So for you guys doing an installation, generally it's just going to work. If you have a fault where it says it's a blower motor fault, something wrong with the blower motor doesn't want to kick on, always check all your plugs. Sometimes things just aren't plugged in all the way. That is like 99% of the time on a brand new install, usually the issue. All this stuff here, your 42 for your inducer motor is all in your manual. This is all stuff that I just copied and pasted off of the manuals from where I found it where I got it online. Limit circuit faults, simple. The furnace overheated. It should never overheat on any of our units because they're constant airflow. If they're overheated, two-stage or modulating furnace, first thing to always check is make sure that the gas pressure is set properly on that unit. Okay, otherwise they generally never ever overheat. 41 again, that's the blower motor. Again, you don't have to worry about this one. This is actually the same. This is something I stole off of the ultra low NOx furnace, but it's still diagnosing that inducer motor 987M. Just some basic voltages to look for. The communication lines, what it does for the inducer motor, your high voltage going to it, and then the signal. All of that is laid out in that manual to talk you through what kind of voltage to look for to make sure. Is it a faulty circuit board or is it a faulty inducer motor? But this is just some basic checks when it's calling for it to come on. Disregard all this. This is all for the ultra low NOx furnace. Okay. This is what I was talking about, that we can spend a whole solid day only on diagnosing and crap, even only on the variable speed equipment. So how many of you guys install variable speed? How many variable speed stuff have you guys been doing?
So a lot.
A lot?
A lot, yeah. Yeah, so probably, I think, maybe 10 installation per month.
Nice.
Yeah, I think it's a lot.
It's a good amount. Yeah, the variable speed equipment is it's just worlds above. This is the wave of the future. This is the way California is going, the way the whole country is going for efficiencies overall. We're going to get to the point where we're not going to be able to reach efficiencies unless we got variable speed equipment. Okay? Which this has been out for a while. You know, it came out with ductless, with the inverter technology, and that's pretty much what all this stuff is right here. I mean, the first time I ever opened up one of these units was a 5-stage heat pump out in the country. I opened it up like 7-8 years ago, and I was like, what the hell? And I know a lot about evolution, and I knew a lot about infinity. Same exact thing. I opened it up, and I was like a freaking monkey. Dude was like scratching my head. Those had a little contactor, right, to power up the board. All the contactor did was close and power up the system. I was like a freaking monkey, man. I was over here pushing the button, like scratching my head. I was like, it won't work. It won't work. I don't know. It's really intimidating. Okay?
Yeah.
Looking at this junk right here, it can be very intimidating. I just came back from Atlanta. I was doing a variable refrigerant flow class, the fancy stuff where it's like one unit that goes to a bunch of different fan coils, right? And the guy thought a lot like I did. And the way I always approach anything, and I mean, I've been called out and say, hey, our AC unit at our office isn't working. And I'll walk up to it and it's this box car, this big old huge thing on the roof with 6 freaking semi-hermetic compressors, all these different controls. And even that could be a little intimidating, even though it's not variable speed. But what it all is, when you look at anything, they're all so damn similar. Refrigerant, every one of them works the exact same way for air conditioning, the refrigerant or heating. You're basically removing heat from one space and tossing it somewhere else. Air conditioning takes heat from here, puts it out there. A heat pump in heating takes heat from out there and puts it in here. Refrigerant does the same thing. A compressor does the exact same work. It still takes refrigerant, compresses it, the refrigerant changes states, fans move around the air, indoor and outdoor and so on. All do the same thing. They all got metering devices. Electronic ones, okay, still regulates the refrigerant. I can still look at refrigerant, I can still look at flow, I can still look at all that. Let me put you at ease, and that's where these manuals all come into place. Even for us. I mean, we touch some equipment here and there, but even for me, Merle, Michael, that are working in the offices, we get all these phone calls. But we're getting phone calls for all Northern California. It is a very good piece of equipment. Number one, installed correctly with proper airflow, proper electrical, proper communication line for these units. The things work flawlessly. The things work freaking fantastic. They're awesome. They're a great piece of equipment. When anything does go wrong, realistically, it's one of a few little things that can be possible. You got to replace a board, or you got to replace a compressor, or you got to replace a motor. I mean, it's simple. Even though there's all this fancy stuff right here, I mean, if your inducer motor doesn't work on a regular unit, what do? You check for voltage, capacitors, play on the bearings, junk that motor, put another one in there. These things do a lot of the work for you. That's why they're so intimidating, but they do so much work for you. Off of a simple diagnostic code that tells you, hey, there's a problem with the inducer motor, or high pressure switch, maybe the inducer motor isn't working. These things know what's going on. So if you think, when you get a locked rotor on one of these, like even a ductless unit, when you get a locked rotor on it, these things are so precise that you look like a locked rotor amp of a 5-ton scroll compressor. It's like 80, 90 amps sometimes. And you go turn on with a hard start kit, and that thing, your meter goes way up high, and then it shuts off, right? Really easy. It's a locked rotor amp. You know you got a locked rotor amp. These things can be pulling 1 or 2 amps, and it knows that at this state, I'm pulling way too much power. I'm not starting. I got a problem. It shuts down. And it flat out tells you. So this table, okay, is on the 288, 180, 189, 288 on the 5-stage. A little bit more simplified, a little bit more of what to look for. But if you look at it and look at it all, I mean, simply when you got a fault, a thermistor fault, a coil temperature fault, those are easy. They're 10K ohm or 100K ohm, whatever they may be. It's just a thermistor. You're just going to ohm it out, check it out, and it's either open. Even if you don't have the resistance chart, when it tells you that a thermistor is open or thermistor is faulty, you check it out, and if you're not getting anywhere near 10K ohms or the numbers don't make sense, it's just a faulty switch and not a faulty board kind of scenario. But thermistors are easy to check. You know, it's got thermistors with this whole crap right here. Again, just don't let it intimidate you overall. The stuff where it gets okay, crap, which one, what am I going to do now? What is it? When you really do get an inverter fault. But this is like a fan inverter fault. Fan inverter fault, that's what I'm talking about. Bam. It's going to tell you to go check out your voltage, or tell you to check out your inverter, your outdoor motor, because maybe the motor is just faulty itself. Simple. Just a little bit extra kind of weird steps compared to a standard condenser fan motor, but it's going to be a simple check. The most difficult, whether if it's this or if it's the Evolution Extreme, when you start getting compressor faults, or lockouts, that there's something wrong with the inverter board, or something wrong with the compressor, in those books, the Evolution Extreme or the 5-stage, you're going to have some simple steps. You're going to check out ohms. Before you say, I'm going to change out the compressor because the compressor doesn't want to start, it's telling me it's got an inverter fault, you check out your compressor. It's got ohm readings in there that your compressor should ohm out to certain readings. Now remember, on these two units, the 5-stage or the Evolution Extreme, they are a variable speed three-phase motor. They're no longer a standard compressor. It's a 3-phase compressor. So you're checking out readings. You go these two, and these two, and the readings they're not all the same. One of the readings is really, really, really goofy. You got a bad compressor. And so if you ever get to that scenario where you're checking that out, you're going to ohm out a condenser fan motor. If it's giving you a fault condenser fan motor, your ohm out condenser fan motor, the numbers don't add up to what like the book says it should for the conditions for like a set temperature. If it's nowhere near it, especially if the numbers don't add up, because all the windings should be equal. If they're not, you got a faulty motor, you got a faulty compressor. But a lot of it, it's, you're going to ohm out condenser fan motor, you're going to ohm out compressor, and especially if it's telling you there's something wrong with the board or something wrong with the compressor. I mean, that's what it really comes down to. When you really read it on some of these faults, it just basically means either both things are bad, or there's something wrong with my inverter board, or there's something wrong with my compressor. And at that point, you can make the call. What can you get quick? You may want to order both. Be prepared. Or just order the new board, replace everything, get it going, you get the same fault code, replace the compressor. If you've ever dealt with ductless, and I'm not talking just even Bryant, I'm talking Mitsubishi, Fujitsu, whatever. I always tell the story about Fujitsu. I used to call them up. I used to hate calling them. Oh man, so I'd call them up, tell them it's having this fault, and they'd tell me, okay, on this board, check here. All right, great. Now what I want you to do is check the electronic expansion valve. Ohm out your compressor. Ohm out your condenser fan motors. We do these little checks. Okay, replace all the boards. Replace everything. Alright, so replace everything. Hey, still doing the same thing. Oh, replace the compressor now. And then it starts working. It's kind of weird to say it that way, but with some of the finer electronics, it really is a step procedure. To sometimes, once you show that your compressor ohms out okay, your condenser fan motor ohms out okay, when it comes to the major failure of it's having an inverter fault or a compressor fault, some of these flat out telling you that it's a compressor fault means replace compressor first. But on these units, if you're replacing the compressor, you're going to want to replace the inverter board too. It'll bite you in the butt sometimes if you don't. Sometimes it's flat out. You can ohm out a compressor and see that the compressor is shorted to ground on these units. Simple diagnostics. Right? My compressor is faulty. My condenser fan motor is faulty. It's shorted to ground. Compressor isn't, but my condenser fan motor is. Sometimes those components can knock out these boards, and we find that both in the Evolution variable speed stuff or even in ductless. Okay? But that's why, I mean, honestly, we can spend freaking 8-10 hours just trying to go step by step, every single little thing. But when you look at these manuals, and you don't really find this stuff on the doors of the units, but this is on the manuals. When you find your fault, it tells you what it is, and then it tells you, well, one is for both heat pump and AC. Some of it's only applies to AC only, because these diagnostic codes are the same for both types of units, both the heat pump unit and the air conditioning unit. And then look at your possible repair, possible thing you got to do. And some is flat out like a system malfunction, like this code, flat out says replace the inverter. But why did that inverter go out?
Good question.
Exactly. First thing you do, again, when you're going to replace an inverter, you're going to replace a board. Some of this stuff is just flat out, it's something's not communicating right. You place the little board, the one that's still on that thing, the little AOC board. But the inverter board comes with everything. So if you come to the conclusion where you got to replace like a main board, like on ductless, it's, you know, the IPM board, whatever. If you're replacing the inverter board because it's telling us that there's something wrong with the board, the communication between both these things are saying there's something wrong over here. It could have just failed. Could have just been some electrical issue that caused it to fail. You, again, check your compressor health by ohming it out. You can't start it, but you can ohm it. If that looks okay, yeah, you're going to replace your inverter. But guess what? Still don't be surprised if you turn it on. Okay. Anything else?
I have 3 small questions,
Yeah.
but it's about site, HVAC partners, error codes reading, where can I find the information about error codes in my connects? I mean, for example, if I have E179 error code, where can I find information about
Yeah,
it?
there's a few weird error codes that aren't listed in these things that have to relate to the Connex. Take down my email. Oh, here. Email me that you want the information, and I'll send it over to you.
Thank you so much.
Yeah, that's for the and it's got like, what I have is like for even older stuff and brand new stuff. Because most of the time you're going to see all these error codes, right? Stuff like
Yep.
this. But sometimes you get some weird ones that have only to do with the Connex communication or something weird.
Mhm.
And yeah, it's not even in the Connex book. It's not even in the install of the Connex.
Yeah, okay. Okay, and the last question about the HVAC parts.
Uh-huh.
The partner site, I want to find, so I have a customer with a system fault, and I want to know, is it possible to,
To see what it looks like?
yep,
Okay. All right, well, let me get out of this. I'm going to close it down and see if it print shows it up there. Oh. Okay, so I'm going to show them something that's probably not for all you guys, but guys, thank you.
thank you so much.
It's a lot of information, man, and I know some of it went kind of quick, but realistically, 3 days would probably be more enough, a little bit at a time, but we just try to get you guys as much info as quickly as possible. Thank you all.
Thank you.
Excuse me.
Yeah.
Before about condenser motor,